Hey friends, so today we are diving into something very exciting, building together a modern SQL data warehouse project. But this one is not any project, this one is a special one. Not only you will learn how to build a modern data warehouse from the scratch, but also you will learn how I implement this kind of projects in real-world companies. I'm Baraa and I have built more than 5 successful data warehouse projects in different companies. And right now I'm leading big data and BI projects at Mercedes-Benz. So that means I'm sharing with you real skills, real knowledge from complex projects. And here's what you will get out of this project. As a data architect, we will be designing a modern data architecture following the best practices, and as a data engineer you will be writing a code to clean, transform, load and prepare the data for analysis. And as a data modeler you will learn the basics of data modeling, and we will be creating from the scratch a new data model for analysis. And my friends, by the end of this project you will have a professional portfolio project to showcase your new skills, for example on LinkedIn. So feel free to take the project, modify it and as well share it with others. But it's gonna mean the world for me if you share my content. And guess what? Everything is for free, so there are no hidden costs at all. And in this project we will be using SQL Server, but if you prefer other databases like MySQL or Postgres, don't worry, you can follow along just fine. Alright my friends, so now if you want to do data analytics projects using SQL, we have 3 different types. The first type of projects you can do data warehousing. It's all about how to organize, structure and prepare your data for data analysis. It is the foundations of any data analytics projects. And in the next step you can do exploratory data analysis, EDA, and all what you have to do is to understand and cover insights about our datasets. In this kind of project you can learn how to ask the right questions and how to find the answer using SQL by just using basic SQL skills. Now moving on to the last stage where you can do advanced analytics projects, where you're gonna use advanced SQL techniques in order to answer business questions like finding trends over time, comparing the performance, segmenting your data into different sections, and as well generate reports for your stakeholders. So here you will be solving real business questions using advanced SQL techniques. Now what we're gonna do, we're gonna start with the first type of projects, SQL data warehousing, where you will gain the following skills. So first you will learn how to do ETL, ELT processing using SQL in order to prepare the data. You will learn as well how to build data architecture, how to do data integrations where we're gonna merge multiple sources together, and as well how to do data load and data modeling. So if I got you interested, grab your coffee and let's jump to the projects. Alright my friends, so now before we deep dive into the tools and the cool stuff, we have first to have good understanding about what is exactly a data warehouse, why the companies try to build such a data management system. So now the question is, what is a data warehouse? I will just use the definition of the father of the data warehouse, Bill Inman. A data warehouse is subject-oriented, integrated, time-variant, and non-volatile collection of data designed to support the management's decision-making process. Okay, I know that might be confusing. Subject-oriented, it means data warehouse is always focused on a business area, like the sales, customers, finance, and so on. Integrated because it goes and integrate multiple source systems. Usually you build a warehouse not only for one source, but for multiple sources. Time variance, it means you can keep historical data inside the data warehouse. Non-volatile, it means once the data enters the data warehouse, it is not deleted or modified. So this is how Bill Inman defined a data warehouse. Okay, so now I'm going to show you the scenario where your company don't have a real data management. So now let's say that you have one system and you have like one data analyst has to go to this system and start collecting and extracting the data. And then he's gonna spend days and sometimes weeks transforming the raw data into something meaningful. Then once they have the report, they're gonna go and share it. And this data analyst is sharing the report using an Excel. And then you have like another source of data and you have another data analyst that she is doing maybe the same steps, collecting the data, spending a lot of time transforming the data, and then share at the end like a report, and this time she is sharing the data using PowerPoint. And a third system and the same story, but this time he is sharing the data using maybe Power BI. So now if the company works like this, then there is a lot of issues. First, this process it takes too way long. I saw a lot of scenarios where sometimes it takes weeks and even months until the employee manually generating those reports. And of course, what's gonna happen for the users? They are consuming multiple reports with multiple state of the data. One report is 40 days old, another one 10 days, and a third one is like 5 days. So it's gonna be really hard to make a real decision based on this structure. A manual process is always slow and stressful, and the more employees you involved in the process, the more you open the door for human errors. And errors, of course, in reports leads to bad decisions. And another issue, of course, is handling the big data. If one of your sources generating like massive amount of data, then the data analyst gonna struggle collecting the data, and maybe in some scenarios it will not be anymore possible to get the data. So the whole process can break and you cannot generate any more fresh data for specific reports. And one last very big issue with that, if one of your stakeholders asks for an integrated report from multiple sources, well, good luck with that, because merging all those data manually is very chaotic, time-consuming, and full of risk. So this is just a picture if a company is working without a proper data management, without a data lake, data warehouse, data lake houses. So in order to make real and good decisions, you need data management. So now let's talk about the scenario of a data warehouse. So the first thing that's gonna happen is that you will not have your data team collecting manually the data. You're gonna have a very important component called ETL. ETL stands for extract, transform, and load. It is a process that you do in order to extract the data from the sources and then apply multiple transformations on those sources. And at the end, it loads the data to the data warehouse. And this one gonna be the single point of truth for analysis and reporting, and it is called data warehouse. So now what can happen? All your reports gonna be consuming this single point of truth. So with that, you create your multiple reports, and as well, you can create integrated reports from multiple sources, not only from one single source. So now by looking to the right side, it looks already organized, right? And the whole process is completely automated. There is no more manual steps, which of course it reduces the human error, and as well it is pretty fast. So usually you can load the data from the sources until the reports in matter of hours or sometimes in minutes. So there is no need to wait like weeks and months in order to refresh anything. And of course, the big advantage is that the data warehouse itself, it is completely integrated. So that means it goes and brings all those sources together in one place, which makes it really easier for reporting. And not only integrated, you can build in the data warehouse as well a history. So we have now the possibility to access historical data. And what is also amazing is that all those reports having the same data status. So all those reports can have the same status, maybe sometimes 1 day old or something. And of course, if you have a modern data warehouse in cloud platforms, you can really easily handle any big data sources. So no need to panic if one of your sources is delivering massive amount of data. And of course, in order to build the data warehouse, you need different types of developers. So usually the one that builds the ETL component and the data warehouse is the data engineer. So they are the one that is accessing the sources, scripting the ETLs, and building the database for the data warehouse. And now for the other part, the one that is responsible for that is the data analyst. They are the one that is consuming the data warehouse, building different data models and reports, and sharing it with the stakeholders. So they are usually contacting the stakeholders, understanding the requirements, and building multiple reports based on the data warehouse. So now if you have a look to those two scenarios, this is exactly why we need data management. Your data team is not wasting time and fighting with the data. They are now more organized and more focused, and with like a data warehouse, and you are delivering professional and fresh reports that your company can count on in order to make good and fast decisions. So this is why you need a data management like a data warehouse. Think about data warehouse as a busy restaurant. Every day, different suppliers bring in fresh ingredients, vegetables, spices, meat, you name it. They don't just use it immediately and throw everything in one pot, right? They clean it, shop it, and organize everything and store each ingredient in the right place, fridge or freezer. So this is the preparing phase. And when the order comes in, they quickly grab the prepared ingredients and create a perfect dish and then serve it to the customers of the restaurant. And this process is exactly like the data warehouse process. It is like the kitchen where the raw ingredients, your data, are cleaned, sorted, and stored. And when you need a report or analysis, it is ready to serve up exactly like what you need. Okay, so now we're gonna zoom in and focus on the component ETL. If you are building such a project, you're gonna spend almost 90% just building this component, the ETL. So it is the core element of the data warehouse, and I want you to have a clear understanding what is exactly an ETL. So our data exists in a source system, and now what we want to do is to get our data from the source and move it to the target. Source and target could be like database tables. So now the first step that we have to do is to specify which data we have to load from the source. Of course, we can say that we want to load everything, but let's say that we are doing incremental loads. So we're gonna go and specify a subset of the data from the source in order to prepare it and load it later to the target. So this step in the ETL process, we call it extract. We are just identifying the data that we need, we pull it out, and we don't change here anything. It's gonna be like one-to-one, like the source system. So the extract has only one task: to identify the data that we have to pull out from the source and to not change anything. So we will not manipulate the data at all. It's gonna stay as it is. So this is the first step in the ETL process, the extract. Now moving on to the stage number 2, we're gonna take this extracted data and we will do some manipulations, transformations, and we're gonna change the shape of those data. And this process is really heavy working. We can do a lot of stuff like data cleansing, data integration, and a lot of formatting and data normalizations. So a lot of stuff we can do in this step. So this is the second step in the ETL process, the transformation. We're gonna take the original data and reshape it, transform it into exactly the format that we need, into a new format and shapes that we need for analysis and reporting. Now finally we get to the last step in the ETL process. We have the load. So in this step we're gonna take this new data and we're gonna insert it into the target. So it is very simple. We're gonna take this prepared data from the transformation step and we're gonna move it into its final destination, the target, like for example data warehouse. So that's ETL in a nutshell. First extract the raw data, then transform it into something meaningful, and finally load it to a target where it's gonna make a difference. So that's it. This is what we mean with the ETL process. Now in real projects, we don't have like only source and targets. Our data architecture gonna have like multiple layers. Depend on your design whether you are building a warehouse or a data lake or a data warehouse. And usually there are like different ways on how to load the data between all those layers. And in order now to load the data from one layer to another one, there are like multiple ways on how to use the ETL process. So usually if you are loading the data from the source to the layer number 1, like only extract the data from the source and load it directly to the layer number 1 without doing any transformations, because I want to see the data as it is in the first layer. And now between the layer number 1 and the layer number 2, you might go and use the full ETL. So we're gonna extract from the layer 1, transform it, and then load it to the layer number 2. So with that, we are using the whole process, the ETL. And now between layer 2 and layer 3, we can do only transformation and then load. So we don't have to deal with how to extract the data, because it is maybe using the same technology, and we are taking all data from layer 2 to layer 3. So we transform the whole layer 2 and then load it to layer 3. And now between 3 and 4, you can use only the L. So maybe it's something like duplicating and replicating the data, and then you are doing the transformation. So you load to the new layer and then transform it. Of course, this is not a real scenario. I'm just showing you that in order to move from source to a target, you don't have to always to use a complete ETL. Depend on the design of your data architecture, you might use only few components from the ETL. Okay, so this is how ETL looks like in real projects. Okay, so now I would like to show you an overview of the different techniques and methods in the ETLs. We have a wide range of possibilities where you have to make decisions on which one you want to apply to your projects. So let's start first with the extraction. The first thing that I want to show you is we have different methods of extraction. Either you are going to the source system and pulling the data from the source, or the source system is pushing the data to the data warehouse. So those are the two main methods on how to extract data. And then we have in the extraction two types. We have a full extraction, everything, all the records from tables, and every day we load all the data to the data warehouse, or we make more smarter one where we say we're gonna do an incremental extraction, where every day we're gonna identify only the new changing data. So we don't have to load the whole thing, only the new data. We go extract it and then load it to the data warehouse. And in data extraction, we have different techniques. The first one is like manually, where someone has to access access a source system and extract the data manually, or we connect ourselves to a database and we have then a query in order to extract the data, or we have a file that we have to parse it to the data warehouse, or another technique is to connect ourselves to API and do their calls in order to extract the data. Or if the data is available in streaming like in Kafka, we can do event-based streaming in order to extract the data. Another way is to use the change data capture, CDC, is as well something very similar to streaming. Or another way is by using web scraping, where you have a code that's gonna run and extract all the informations from the web. So those are the different techniques and types that we have in the extraction. Now, if you are talking on the transformation, there are a wide range of different transformations that we can do on our data. Like for example, doing data enrichment, where we add values to our data sets, or we do a data integration where we have multiple sources and we bring everything to one data model, or we derive new columns based on already existing one. Another type of data transformations, we have the data normalization. So the sources has values that are like a code and you go and map it to more friendly values for the analyzers, which is more easier to understand and to use. Another transformations, we have the business rules and logic. Depend on the business, you can define different criteria in order to build like new columns. And what belongs to transformations is the data aggregation. So here we aggregate the data to a different granularity, and then we have type of transformation called data cleansing. There are many different ways on how to clean our data. For example, removing the duplicates, doing data filtering, handling the missing data, handling invalid values, or removing unwanted spaces, casting the data types, and detecting the outliers, and many more. So we have different types of data cleansing that we can do in our data warehouse, and this is very important transformation. So as you can see, we have different types of transformations that we can do in our data warehouse. Now moving on to the load. So what do we have over here? We have different processing types. So either we are doing batch processing or stream processing. Batch processing means we are loading the data warehouse in one big batch of data that's gonna run and load the data warehouse. So it is only one-time job in order to refresh the content of the data warehouse and as well the reports. So that means we are scheduling the data warehouse in order to load it in the day once or twice. And the other type, we have the stream processing. So this means if there is like a change in the source system, we're gonna process this change as soon as possible. So we're gonna process it through all the layers of the data warehouse once something changes from the source system. So we are streaming the data in order to have real-time data warehouse, which is very challenging things to do in data warehousing. And if you are talking about the loads, we have two methods. Either we are doing a full load or incremental load. It's the same thing as extraction, right? So for the full load in databases, there are like different methods on how to do it. Like for example, we truncate and then insert. That means we make the table completely empty and then we insert everything from the scratch. Or another one, you are doing an update insert. We call it upsert. So we can go and update all the records and then insert the new one. And another way is to drop, create and insert. So that means we drop the whole table and then we create it from scratch and then we insert the data. It is very similar to the truncate, but here we are as well removing and dropping the whole table. So those are the different methods of full loads. The incremental load, we can use as well the upserts, so update and insert. So we're gonna do an update or insert statements to our tables. Or if the source is something like a log, we can do only insert. So we can go and append the data always to the table without having to update anything. Another way to do incremental load is to do a merge, and here it is very similar to the upsert but as well with a delete. So update, insert, delete. So those are the different methods on how to load the data to your tables. And one more thing, in data warehousing we have something called slowly changing dimensions. So here it's all about the historizations of your table, and there are many different ways on how to handle the historizations in your table. The first type is SCD0. We say there is no historizations and nothing should be changed at all. So that means you are not going to update anything. The second one, which is more famous, it is the SCD1. You are doing an overwrite. So that means you are updating the records with the new information from the source system by overwriting the old value. So we are doing something like the upsert. So update and insert. But you are losing, of course, history. Another one, we have the SCD2, and here you want to add historizations to your table. So what we do, each change that we get from the source system, that means we are inserting new records and we are not going to overwrite or delete the old data. We are just going going to make it inactive, and the new record gonna be active one. So there are different methods on how to do historizations as well while you are loading the data to the data warehouse. Alright, so those are the different types and techniques that you might encounter in data management projects. So now what I'm gonna show you quickly which of those types we will be using in our projects. So now if we are talking about the extraction over here, we will be doing a pull extraction, and about the full or incremental, it's gonna be a full extraction, and about the technique, we are going to be parsing files to the data warehouse. And now about the data transformations, well, this one we will cover everything. All those types of transformations that I'm showing you now is going to be part of the project, because I believe in each data project you will be facing those transformations. Now if you have a look to the load, our project is going to be batch processing, and about the load methods, we will be doing a full load since we have full extraction, and it's going to be truncate and inserts. And now about the historizations, we will be doing the SCD1, so that means we will be updating the content of the data warehouse. So those are the different techniques and types that we will be using in our ETL process for this project. Alright, so with that we have now clear understanding what is a data warehouse, and we are done with the theory part. So now the next step, we're gonna start with the project. The first thing that we have to do is to prepare our environment to develop the project. So let's start with that. Alright, so now we go to the link in the description, and from there we're gonna go to the downloads, and here you can find all the materials of all courses and projects, but the one that we need now is the SQL Data Warehouse projects. So let's go to the link, and here we have a bunch of links that we need for the projects, but the most important one to get all data and files is this one, download all project files. So let's go and do that, and after you do that you're gonna get a zip file where you have there a lot of stuff. So let's go and extract it, and now inside it, if you go over here, you will find the repository structure from Git, and the most important one here is the data sets. So you have two sources, the CRM and the ERP, and in each one of them there are 3 CSV files. So those are the data sets for the projects. For the other stuffs, don't worry about it, we will be explaining that during the project. So go and get the data and put it somewhere at your PC where you don't lose it. Okay, so now what else do we have? We have here a link to the Git repository. So this is the link to my repository that I have created through the projects. So you can go and access it, but don't worry about it. We're going to explain the whole structure during the project, and you will be creating your own repository. And as well, we have the link to the Notion. Here we are doing the project management. Here you're going to find the main steps, the main phases of the SQL projects that we will do, and as well all the tasks that we will be doing together during the projects. And now we have links to the project tools. So if you don't have it already, go and download the SQL Server Express. So it's like a server that's gonna run locally at your PC where your database gonna live. Another one that you have to download is the SQL Server Management Studio. It is just a client in order to interact with the database, and there we're gonna run all our queries. And then link to the GitHub, and as well a link to the Draw.io. If you don't have it already, go and download it. It is free and amazing tool in order to draw diagrams. So through the projects we will be drawing data models, the data architecture, a data lineage. So a lot of stuff we'll be doing using this tool. So go and download it. And the last thing, it is nice to have, you have a link to the Notion where you can go and create, of course, free accounts if you want to build the project plan, and as well follow me by creating the project steps and the project tasks. Okay, so that's all. Those are all the links for the projects. So go and download all those stuff, create the accounts, and once you are ready, then we continue with the projects. Alright, so now I hope that you have downloaded all the tools and created the accounts. Now it's time to move to a very important step that almost all people skip while doing projects, and that is by creating the project plan. And for that, we will be using the tool Notion. Notion is, of course, a free tool, and it's gonna help you to organize your ideas, your plans, and resources all in one place. I use it very intensively for my private projects, like for example, creating this course. And I can tell you, creating a project plan is the key to success. Creating a data warehouse project is usually very complex, and according to Gartner reports, over 50% of data warehouse projects fail. And my opinion about any complex project, the key to success is to have a clear project plan. So now at this phase of the project, we're gonna go and create a rough project plan because at the moment we don't have yet clear understanding about the data architecture. So let's go. Okay, so now let's create a new page and let's call it Data Warehouse Projects. The first thing is that we have to go and create the main phases and stages of the project. And for that, we need a table. So in order to do that, hit slash and then type database inline. And then let's go and call it something like Data Warehouse Epics. And we're going to go and hide it because I don't like it. And then on the table, we can go and rename it. Like for example, projects Epics, something like that. And now what we're going to do, we're going to go and list all the big tasks of the project. So an epic is usually like a large task that needs a lot of efforts in order to solve it. So you can call it epics, stages, phases of the project, whatever you want. So we're going to go and list our project steps. So it starts with the requirements, analyzes, and then designing, data architecture. And another one we have the project's initialization. So those are the three big tasks in the project first. And now what do we need? We need another table for the small chunks of the tasks, the subtasks. And we're going to do the same thing. So we're going to go and hit slash and we're going to search for the table inline. And we're going to do the same thing. So first we're going to call it data warehouse tasks. And then we're going to hide it. And over here, we're going to rename it and say this is the project tasks. So now what we're going to do, we're going to go to the plus icon over here and then search for relation, this one over here with the arrow. And now we're going to search for the name of the first table. So we called it Data Warehouse Epics. So let's go and click it. And we're going to say as well, two-way relation. So let's go and add the relation. So with that, we got a field in the new table called Data Warehouse Epics. This comes from this table. And as well, we have here Data Warehouse Tasks that comes from the below table. So as you can see, we have linked them together. Now what I'm going to do, I'm going to take this to the left side. And then what we're going to do, we're going to go and select one of those epics. Like for example, let's take design the data architecture. And now what we're going to do, we're going to go and break down this epic into multiple tasks. Like for example, choose data management approach. And then we have another task. What we're going to do, we're going to go and select as well the same epic. So maybe the next step is brainstorm and design the layers. And then let's go to another epic, for example, the project initialization. And we say over here, for example, create, get repo, prepare the structure. We can go and make another one in the same epic. Let's say we're going to go and create the database and the schemas. So as you can see, I'm just defining the subtasks of those epics. So now what we're going to do, we're going to go and add a checkbox in order to understand whether we have done the task or not. So we go to the plus and search for check. We need a checkbox. And what we're going to do, we're going to make it really small, like this. And with that, each time we are done with the task, we're gonna go and click on it just to make sure that we have done the task. Now there is one more thing that is not really working nice, and that is here. We're gonna have like a long list of tasks and it's really annoying. So what we're gonna do, we're gonna go to the plus over here and let's search for roll up. So let's go and select it. So now what we're going to do, we have to go and select the relationship. It's going to be the data warehouse task. And after that, we're going to go to the property and make it as a checkbox. So now, as you can see in the first table, we are saying how many tasks is closed, but I don't want to show it like this. What you're going to do, we're going to go to the calculation and to the percent and then percent checked. And with that, we can see the progress of our project. And now instead of the numbers, we can have really nice bar. Great. So as well, we can go and give it a name like progress. So that's it. And we can go and hide the data warehouse tasks. And now with that, we have really nice progress bar for each epic. And if we close all the tasks of this epic, we can see that we have reached 100%. So this is the main structure. Now we can go and add some cosmetics and rename stuff in order to make things look nicer. Like for example, if I go to the tasks over here, I can go and call it tasks and as well go and change the icon to something like this. And if you'd like to have an icon for all those epics, what you're going to do, we're going to go to the epic, for example, design data architecture. And then if you hover on top of the title, you can see add an icon and you can go and pick any icon that's you want. So for example, this one. And now as you can see, we have defined it here in the top and the icon gonna be as well in the below table. Okay, so now one more thing that we can do for the project tasks is that we can go and group them by the epics. So if you go to the three dots and then we go to groups and then we can group up by the epics. And as you can see now we have like a section for each epic and you can go and sort the epics if you want. If you go over here, sort, then manual, and you can go over here and start sorting the epics as you want. want. And with that, you can expand and minimize each task if you don't want to see always all tasks in one go. So this is a really nice way in order to build like data management for your projects. Of course, in companies, we use professional tools in order to do projects, like for example Jira. But for private personal projects that I do, I always do it like this. And I really recommend you to do it, not only for this project, for any project that you are doing, because if you see the whole project in one go, you can see the big picture. And closing tasks and doing it like this, these small things can make you really satisfied and keeps you motivated to finish the whole project and makes you proud. Okay friends, so now I just went and added few icons, renamed stuff, and as well more tasks for each epic. And this is gonna be our starting point in the project. And once we have more informations, we're gonna go and add more details on how exactly we're gonna build the data warehouse. So at the start, we're gonna go and analyze and understand the requirements, and only after that, we're gonna start designing the data architecture. And here we have 3 tasks. First, we have to choose the data management approach. And after that, we're gonna do brainstorming and designing the layers of the data warehouse. And at the end, we're gonna go and draw a data architecture. So with that, we have clear understanding how the data architecture looks like. And after that, we're gonna go to the next epic, where we're gonna start preparing our projects. So once we have clear understanding of the data architecture, the first task here is to go and create detailed project tasks. So we're gonna go and add more epics and more tasks. And once we are done, then we're gonna go and create the naming conventions for the projects, just to make sure that we have rules and standards in the whole project. And next, we're gonna go and create a repository in the Git. And we're gonna prepare as well the structure of the repository, so that we always commit our work there. And then we're gonna start with the first script, where we're gonna create a database and schemas. So my friends, this is the initial plan for the project. Now let's start with the first epic. We have the requirements analysis. Now, analyzing the requirement, it is very important to understand which type of data warehouse you're going to go and build, because there is like not only one standard on how to build it. And if you go blindly implementing the data warehouse, you might be doing a lot of stuff that is totally unnecessary, and you will be burning a lot of time. So that's why you have to sit with the stakeholders, with the department, and understand what we exactly have to build. And depend on the requirements, you design the shape of the data warehouse. So now let's go and analyze the requirement of this project. Now, the whole project is split into 2 main sections. The first section, we have to go and build a data warehouse. So this is a data engineering task, and we will go and develop ETLs and data warehouse. And once we have done that, we have to go and build analytics and reporting, business intelligence. So we're gonna do data analysis. But now first, we will be focusing on the first part, building the data warehouse. So what do we have here? The statement is very simple. It says, develop a modern data warehouse using SQL Server to consolidate sales data, enabling analytical reporting and informed decision making. So this is the main statements, and then we have specifications. The first one is about the data sources. It says import data from 2 source systems, ERP and CRM, and they are provided as CSV files. And now the second task is talking about the data quality. We have to clean and fix data quality issues before we do the data analysis, because let's be real, there is no raw data that is perfect. It's always messy, and we have to clean that up. Now the next task is talking about the integration. So it says we have to go and combine both of the sources into one single user-friendly data model that is designed for analytics and reporting. So that means we have to go and merge those 2 sources into one single data model. And now we have here another specifications. It says focus on the latest data sets. So there is no need for historization. So that means we don't have to go and build histories in the database. And the final requirement is talking about the documentation. So it says provide clear documentations of the data model. So that means the last product of the data warehouse to support the business users and the analytical teams. So that means we have to generate a manual that's gonna help the users. That makes lives easier for the consumers of our data. So as you can see, maybe this is very generic requirements, but it has a lot of information already for you. So it's saying that we have to use the platform SQL Server. We have 2 source systems using the CSV files, and it sounds that we really have a bad data quality in the sources, and as well it wants us to focus on building completely new data model that is designed for reporting. And it says we don't have to do historization, and it is expected from us to generate documentations of the system. So these are the requirements for the data engineering part, where we're gonna go and build a data warehouse that fulfill these requirements. Alright, so with that we have analyzed the requirements, and as well we have closed the first easiest epic. So we are done with this. Let's go and close it, and now let's open another one. Here we have to design the data architecture, and the first task is to choose data management approach. So let's go. Now, designing the data architecture, it is exactly like building a house. So before construction starts, an architect's gonna go and design a plan, a blueprint for the house, how the rooms will be connected, how to make the house functional, safe, and wonderful. And without this blueprint from the architects, the builders might create something unstable, inefficient, or maybe unlivable. The same goes for data projects. A data architect is like a house architect. They design how your data will flow, integrate, and be accessed. So as data architects, we make sure that the data warehouse is not only functioning, but also scalable and easy to maintain. And this is exactly what we will do now. We will play the role of the data architect, and we will start brainstorming and designing the architecture of the data warehouse. So now I'm going to show you a sketch in order to understand what are the different approaches in order to design a data architecture. And this phase of the projects usually is very exciting for me, because this is my main role in data projects. I am a data architect, and I discuss a lot of different projects where we try to find out the best design for the projects. Alright, so now let's go. Now, the first step of building a data architecture is to make a very important decision to choose between four major types. The first approach is to build a data warehouse. It is very suitable if you have only structured data and your business want to build solid foundations for reporting and business intelligence. And another approach is to build a data lake. This one is way more flexible than a data warehouse, where you can store not only structured data but as well semi and unstructured data. We usually use this approach if you have mixed types of data, like database tables, logs, images, videos, and your business want to focus not only on reporting but as well on advanced analytics or machine learning. But it's not that organized like a data warehouse. And data lakes, if it's too much unorganized, can turn into data swamp, and this is where we need the next approach. So the next one, we can go and build data lake house. So it is like a mix between data warehouse and data lake. You get the flexibility of having different types of data from the data lake, but you still want to structure and organize your data like we do in the data warehouse. So you mix those two worlds into one, and this is a very modern way on how to build data architecture, and this is currently my favorite way of building data management system. Now, the last and very recent approach is to build a data mesh. So this is a little bit different. Instead of having centralized data management system, the idea now in the data mesh is to make it decentralized. You cannot have like one centralized data management system, because always if you say centralized, then it means bottleneck. So instead you have multiple departments and multiple domains where each one of them is building a data product and sharing it with the others. So now you have to go and pick one of those approaches, and in this project we will be focusing on the data warehouse. So now the question is how to build the data warehouse. Well, there is as well 4 different approaches on how to build it. The first one is the in-one approach. So again, you have your sources, and the first layer you start with the staging where the raw data is landing, and then the next layer you organize your data in something called enterprise data warehouse, where you go and model the data using the third normal format. It's about like how to structure and normalize your tables. So you are building a new integrated data model from the multiple sources, and then we go to the third layer. It's called the data marts, where you go and take like small subset of the data warehouse and you design it in a way that is ready to be consumed from reporting, and it focuses on only one topic, like for example the customers, sales, or products. And after that you go and connect your BI tool like Power BI or Tableau to the data marts. So with that you have 3 layers to prepare the data before reporting. Now moving on to the next one, we have the Campbell approach. He says, you know what, building this enterprise data warehouse, it is wasting a lot of time. So what we can do, we can jump immediately from the stage layer to the final data marts. Because building this enterprise data warehouse, it is a big struggle and usually wastes a lot of time. So he always wants you to focus on building the data marts quickly as possible, so it is faster approach than in one. But with the time you might get chaos in the data marts because you are not always focusing on the big picture and you might be repeating same transformations and integrations in different data marts. So there is like trade-off between the speed and consistent data warehouse. Now moving on to the third approach, we have the data vault. So we still have the stage and the data marts, but it says we still need this central data warehouse in the middle, but this middle layer we're gonna bring more standards and rules. So it tells you to split this middle layer into two layers, the raw vault and the business vault. In the raw vault, you have the original data, but in the business vault, you have all the business rules and transformations that prepares the data for the data marts. So data vault, it is very similar to the in1, but it brings more standards and rules to the middle layer. Now I'm gonna go and add a fourth one that I'm gonna call it medallion architecture. And this one is my favorite one because it is very easy to understand and to build. So it says you're gonna go and build 3 layers: bronze, silver, and gold. The bronze layer, it is very similar to the stage, but we have understood with the time that the stage layer is very important because having the original data as it is, it's gonna help a lot by traceability and finding issues. Then the next layer, we have the silver layer. It is where we do transformations, data cleansing, but we don't apply yet any business rules. Now moving on to the last layer, the gold layer. It is as well very similar to the data marts, but there we can build different type of objects, not only for reporting, but as well for machine learning, for AI, and for many different purposes. So they are like business-ready objects that you want to share as a data product. So those are the 4 approaches that you can use in order to build a data warehouse. So again, if you are building a data architecture, you have to specify which approach you want to follow. So at the start we said we want to build a data warehouse, and then we have to decide between those 4 approaches on how to build a data warehouse. And in this project, we will be using the medallion architecture. So this is a very important question that you have to answer as the first step of building a data architecture. Alright, so with that you have decided on the approach, so we can go and mark it as done. The next step, we're gonna go and design the layers of the data warehouse. Now there is like not 100% standard way and rules for each layer. What you have to do as a data architect, you have to define exactly what is the purpose of each layer. So we start with the bronze layer. So we say it's gonna store raw and unprocessed data as it is from the sources. And why we are doing that? It is for traceability and debugging. If you have a layer where you are keeping the raw data, it is very important to have the data as it is from the sources, because we can go always back to the bronze layer and investigate the data of specific source if something goes wrong. So the main objective is to have raw, untouched data that's gonna help you as a data engineer by analyzing the root cause of issues. Now moving on to the silver layer, it is the layer where we're gonna store clean and standardized data. And this is the place where we're gonna do basic transformations in order to prepare the data for the final layer. Now for the gold layer, it's gonna contain business-ready data. So the main goal here is to provide data that could be consumed by business users and analysts in order to build reporting and analytics. So with that, we have defined the main goal for each layer. Now next, what I would like to do is to define the object types. And since we are talking about a data warehouse and database, we have here generally 2 types, either a table or a view. So we are going for the bronze layer and the silver layer with tables, but for the gold layer, we are going with the views. So the best practice says for the last layer in your data warehouse, make it virtual using views. It's gonna gives you a lot of dynamic and of course speed in order to build it, since we don't have to make a load process for it. And now the next step is that we're gonna go and define the load method. So in this project, I have decided to go with the full load using the method of truncating and inserting. It is just faster and way easier. So we're gonna say for the bronze layer, we're gonna go with the full load, and you have to specify as well for the silver layer as well. We're gonna go with the full load, and of course for the views, we don't need any load process. So each time you decide to go with tables, you have to define the load methods with our full load, incremental loads, and so on. Now we come to the very interesting part, the data transformations. Now for the bronze layer, it is the easiest one about this topic because we don't have any transformations. We have to commit ourselves to not touch the data. Do not manipulate it. Don't change anything. So it's gonna stay as it is. If it comes bad, it's gonna stay bad in the bronze layer. And now we come to the silver layer where we have the heavy lifting. As we committed in the objective, we have to make clean and standardized data. And for that, we have different types of transformations. So we have to do data cleansing, data standardizations, data normalizations. We have to go and derive new columns and data enrichment. So there are like a bunch of transformations that we have to do in order to prepare the data. Our focus here is to transform the data to make it clean and following standards, and try to push all business transformations to the next layer. So that means in the gold layer, we will be focusing on business transformations that is needed for the consumers, for the use cases. So what we do here, we do data integrations between source system, we do data aggregations, we apply a lot of business logics and rules, and we build a data model that is ready for example, business intelligence. So here we do a lot of business transformations, and in the silver layer, we do basic data transformations. So it is really here very important to make the fine decisions what type of transformations to be done in each layer, and make sure that you commit to those rules. Now the next aspect is about the data modeling. In the bronze layer and the silver layer, we will not break the data model that comes from the source system. So if the source system deliver 5 tables, we're gonna have here like 5 tables, and as well in the silver layer, we will not go and denormalize or normalize or like make something new. We're gonna leave it exactly like it comes from the source system. Because what we're gonna do, we're gonna build the data model in the gold layer. And here you have to define which data model you want to follow. Are you following the star schema, the Snowflake, or are you just making aggregated objects? So you have to go and make a list of all data models types that you're gonna follow in the gold layer. And at the end, what you can specify in each layer is the target audience. And this is of course a very important decision. In the bronze layer, you don't want to give access to any end user. It is really important to make sure that only data engineers access the bronze layer. It makes no sense for data analysts or data scientists to go to the bad data, because you have a better version for that in the silver layer. So on the silver layer, of course, the data engineers have to have an access to it, and as well the data analysts and the data scientists and so on. But still, you don't give it to any business user that can't deal with the raw data model from the sources. Because for the business users, you're gonna get a better layer for them, and that is the gold layer. So the gold layer, it is suitable for the data analyst and as well the business users, because usually the business users don't have a deep knowledge on the technicality of the silver layer. So if you are designing multiple layers, you have to discuss all those topics and make clear decision for each layer. Alright my friends, so now before we proceed with the design, I want to tell you a secret principle concept that each data architect must know, and that is the separation of concerns. So what is that? As you are designing an architecture, you have to make sure to break down the complex system into smaller independent parts, and each part is responsible for a specific task. And here comes the magic. The component of your architecture must not be duplicated, so you cannot have two parts are doing the same thing. So the idea here is to not mix everything. And this is one of the biggest mistakes in any big projects. And I've seen that almost everywhere. So a good data architects follow this concept, this principle. So for example, if you are looking to our data architecture, we have already done that. So we have defined a unique set of tasks for each layer. So for example, we have said in the silver layer, we do data cleansing, but in the gold layer, we do business transformations. And with that, you will not be allowing to do any business transformations in the silver layer, and the same thing goes for the gold layer. You don't do in the gold layer any data cleansing. So each layer has its own unique tasks, and the same thing goes for the bronze layer and the silver layer. You do not allow to load data from the source systems directly to the silver layer, because we have decided the landing layer, the first layer, is the bronze layer. Otherwise, you will have like set of source systems that are loaded first to the bronze layer, and another set is skipping the layer and going to the silver. And with that, we have overlapping. You are doing data ingestion in two different layers. So my friends, if you have this mindset, separation of concerns, I promise you, you're gonna be a top data architect. So think about it. Alright my friends, so with that we have designed the layers of the data warehouse. We can go and close it. The next step, we're gonna go to Draw.io and start drawing the data architecture. So there is like no one standard on how to build a data architecture. You can add your style and the way that you want. So now the first thing that we have to show in data architecture is the different layers that we have. The first layer is the source system layer. So let's go and take a box like this and make it a little bit bigger. And now I'm just gonna go and make the design. So I'm gonna remove the fill and make the line dotted one. And after that, I'm gonna go and change maybe the color to something like this, gray. So now we have like a container for the first layer, and then we have to go and add like a text on top of it. So what I'm gonna do, I'm gonna take another box. Let's go and type inside it sources. And now I'm gonna go and style it. So I'm gonna go to the text and make it maybe 24. And then remove the lines like this, make it a little bit smaller and put it on top. So this is the first layer. This is where the data come from. And then the data gonna go inside a data warehouse. So I'm just gonna go and duplicate this one. This one is the data warehouse. Alright, so now the third layer, what is gonna be? It's gonna be the consumers who will be consuming this data warehouse. So I'm gonna put another box and say this is the consume layer. Okay, so those are the three containers. Now inside the data warehouse, we have decided to build it using the Medallion architecture. So we're gonna have three layers inside the warehouse. So I'm gonna take again another box. I'm gonna call this one. This is the bronze layer. And now we have to go and put a design for it. So I'm gonna go with this color over here, and then the text, and maybe something like 20. And then make it a little bit smaller and just put it here. And beneath that, we're gonna have the component. So this is just a title of a container. So I'm gonna have it like this. Remove the text from inside it and remove the filling. So this container is for the bronze layer. Let's go and duplicate it for the next one. So this one gonna be the silver layer. And of course we can go and change the coloring to gray because it is silver, and as well the lines, and remove the filling. Great. And now maybe I'm gonna make the font as bold. Alright, now the third layer gonna be the gold layer. And we have to go and pick a color for that. So style, and here we have like something like yellow. The same thing for the container, and remove the filling. So with that, we are showing now the different layers inside our data warehouse. Now those containers are empty. What we're gonna do, we're gonna go inside each one of them and start adding content. So now in the sources, it is very important to make it clear what are the different types of source systems that you are connecting to the data warehouse. Because in a real project, there are like multiple types. You might have a database, API, files, Kafka, and here it's important to show those different types. In our projects, we have folders, and inside those folders, we have CSV files. So now what you have to do, we have to make it clear in this layer that the input for our project is CSV file. So it really depends how you want to show that. I'm gonna go over here and say maybe folder, and then I'm gonna go and take the folder and put it here inside, and then maybe search for file, more results, and go pick one of those icons. For example, I'm going to go with this one over here. So I'm going to make it smaller and add it on top of the folder. So with that, we make it clear for everyone seeing the architecture that the sources is not a database, is not an API, it is a file inside the folder. So now very important here to show is the source systems. What are the sources that is involved in the project? So here what we're going to do, we're going to go and give it a name. For example, we have one source called CRM, bold like this, and maybe make the icon. And we have another source called ERP. So we're going to go and duplicate it, put it over here, and then rename it ERP. So now it is for everyone clear. We have two sources for this project, and the technology is used is simply a file. So now what we can do as well, we can go and add some descriptions inside this box to make it more clear. So what I'm going to do, I'm going to take a line because I want to split the description from the icons, something like this, and make it gray. And then below it, we're going to go and add some text, and we're going to say is CSV file. And the next point, and we can say the interface is simply files in folder. And of course, you can go and add any specifications and explanation about the sources. If it is a database, you can say the type of the database and so on. So with that, we made it in the data architecture clear what are the sources of our data warehouse. And now the next step, what we're going to do, we're going to go and design the content of the bronze, silver, and gold. So now I'm going to start by adding like an icon in each container. It is to show about that we are talking about database. So what we're going to do, we're going to go and search for database, and then more results. I'm going to go with this icon over here. So let's go and make it bigger, something like this, maybe. Change the color of that. So we're going to have the bronze, and as well here the silver and the gold. So now what we're going to do, we're going to go and add some arrows between those layers. So we're we're gonna go over here. So we can go and search for arrow and maybe go and pick one of those. Let's go and put it here. And we can go and pick a color for that. Maybe something like this and adjust it. So now we're gonna have this nice arrow between all the layers just to explain the direction of our architecture, right? So we can read it from left to right and as well between the gold layer and the consume. Okay, so now what I'm gonna do next, we're gonna go and add one statement about each layer, the main objective. So let's go and grab a text and put it beneath the database. And we're gonna say, for example, for the bronze layer, it's gonna be the raw data. Maybe make the text bigger. So you are the raw data. And then the next one, in the silver, you are clean standard data. And then the last one for the gold, we can say business ready data. So with that, we make the objective clear for each layer. Now below all those icons, what we're gonna do, we're gonna have a separator again, like this, make it like colored, and beneath it, we're gonna add the most important specifications of this layer. So let's go and add those separators in each layer. Okay, so now we need a text below it. Let's take this one here. So what is the object type of the bronze layer? It's gonna be a table. And we can go and add the load method. We say this is batch processing. Since we are not doing streaming, we can say it is a full load. We are not doing incremental load. So we can say here trunk and insert. And then we add one more section maybe about the transformations. So we can say no transformations. And one more about the data model. We're gonna say none as is. And now what I'm going to do, I'm going to go and add those specifications as well for the silver and gold. So here what we have discussed, the object type, the load process, the transformations, and whether we are breaking the data model or not. The same thing for the gold layer. So I can say with that we have really nice layering of the data warehouse, and what we are left is with the consumers over here. You can go and add the different use cases and tools that can access your data warehouse. Like for example, I'm adding here business intelligence and reporting, maybe using Power BI or Tableau. Or you can say you can access my data warehouse in order to do ad hoc analysis using the SQL queries, and this is what we're going to focus on the projects after we build the data warehouse. And as well, you can offer it for machine learning purposes. And of course, it is really nice to add some icons in your architecture. And usually I use this nice website called Flat Icon. It has really amazing icons that you can go and use it in your architecture. Now, of course, we can go and keep adding icons and stuff to explain the data architecture and as well the system. Like for example, it is very important here to say which tools you are using in order to build this data warehouse. Is it in the cloud? Are you using Azure, Databricks, or maybe Snowflake? So we're going to go and add for our projects the icon of SQL Server, since we are building this data warehouse completely in the SQL Server. So for now, I'm really happy about it. As you can see, we have now a plan, right? Alright guys, so with that we have designed the data architecture using the Draw.io, and with that we have done the last step in this epic, and now with that we have a design for the data architecture, and we can say we have closed this epic. Now let's go to the next one. We will start doing the first step to prepare our projects, and the first task here is to create a detailed project plan. Alright my friends, so now it's clear for us that we have 3 layers and we have to go and build them. So that means our big epic is gonna be after the layers. So here I have added 3 more epics. So we have build bronze layer, build silver layer, and gold layer. And after that I went and started defining all the different tasks that we have to follow in the projects. So at the start we will be analyzing, then coding, and after that we're gonna go and do testing. And once everything is ready, we're gonna go and document stuff, and at the end we have to commit our work in the Git repo. All those epics are following the same pattern in the tasks. So as you can see now, we have a very detailed project structure, and now things are more clear for us how we're gonna build the data warehouse. So with that, we are done from this task, and now the next task, we have to go and define the naming convention of the project. Alright, so now at this phase of the project, we usually define the naming conventions. So what is that? It is a set of rules that you define for naming everything in the project, whether it is a database, schema, tables, stored procedures, folders, anything. And if you don't do that at the early phase of the project, I promise you chaos can happen. Because what's gonna happen, you will have different developers in your project, and each of those developers have their own style, of course. So one developer might name a table dimension dimension customers, where everything is lowercase and between them underscore. And you have another developer creating another table called dimension products, but using the camel case. So there is no separation between the words and the first character is capitalized. And maybe another one using some prefixes like dim underscore categories. So we have here like a shortcut of the dimension. So as you can see, there are different designs and styles. And if you leave the door open, what can happen in the middle of the project, you will notice, okay, everything looks inconsistent and you're going to define a big task to go and rename everything following a specific rule. So instead of wasting all this time, at this phase, you go and define the naming conventions. And let's go and do that. So we usually start with a very important decision, and that is which naming convention we're gonna follow in the whole project. So you have different cases like the camel case, the Pascal case, the kebab case, and the snake case. And for this project, we're gonna go with the snake case, where all the letters of a word gonna be lowercase, and the separation between words gonna be an underscore. For example, a table name called customer info. Customer is lowercase, info is as well lowercase, and between them an underscore. So this is always the first thing that you have to decide for your data project. The second thing is to decide the language. So for example, I work in Germany, and there is always like a decision that we have to make whether we use Germany or English. So we have to decide for our project which language we're gonna use. And a very important general rule is that avoid reserved words. So don't use SQL reserved word as an object name. Like for example, table. Don't give a table name as a table. So those are the general principles. So those are the general rules that you have to follow in the whole project. This applies for everything, for tables, columns, stored procedures, any names that you are giving in your scripts. Now moving on, we have specifications for the table names. And here we have different set of rules for each layer. So here the rule says source system underscore entity. So we are saying all the tables in the bronze layer should start first with the source system name, like for example CRM or ARB, and after that we have an underscore, and then at the end we have the entity name or the table name. So for example, we have this table name CRM underscore, so that means this table comes from the source system CRM, and then we have the table name, the entity name, customer info. So this is the rule that we're gonna follow in naming all tables in the bronze layer. Then moving on to the silver layer, it is exactly like the bronze, because we are not going to rename anything, we are not going to build any new data model, so the naming gonna be one-to-one like the bronze. So it is exactly the same rules as the bronze, but if we go to the gold, here since we are building a new data model, we have to go and rename things. And since as well we are integrating multiple sources together, we will not be using the source system name in the tables, because inside one table you could have multiple sources. So the rule says all the names must be meaningful, business-aligned names for the tables, starting with the category prefix. So here the rule says it starts with category, then underscore, and then entity. Now what is category? We have in the gold layer different types of tables. So we could build a table called a fact table, another one could be a dimension, a third type could be an aggregation or a report. So we have different types of tables, and we can specify those types as a prefix at the start. So for example, we are saying here a fact underscore sales. So the category is a fact and the table name called sales. And here I just made like a table with different type of patterns. So we could have a dimension. So we say it starts with the dim underscore, for example, dim customers or products. And then we have another type called fact table. So it starts with fact underscore, or aggregated table, where we have the first three characters, like aggregating the customers or the sales monthly. So as you can see, as you are creating a naming convention, you have first to make it clear what is the rule, describe each part of the rule, and start giving examples. So with that, we make it clear for the whole team which names they should follow. So we talked here about the table naming convention, then you can as well go and make a naming convention for the columns. Like for example, in the gold layer, we're gonna go and have surrogate keys. So we can define it like this. The surrogate key should start with a table name and then underscore a key. Like for example, we can call it customer underscore key. It is a surrogate key in the dimension customers. The same thing for technical columns. As a data engineer, we might add our own columns to the tables that don't come from the source system. And those columns are the technical columns, or sometimes we call them metadata columns. Now, in order to separate them from the original columns that comes from the source system, we can have like a prefix for that. Like for example, the rule says, if you are building any technical or metadata columns, the column should start with DWH underscore and then the column name. For example, if you want the metadata load date, we can have DWH underscore load date. So with that, if anyone sees that column starts with DWH, we understand this data comes from a data engineer, and we can keep adding rules, like for example the storage procedure over here. If we are making an ETL script, then it should start with the prefix load underscore and then the layer. For example, the storage procedure that is responsible for loading the bronze gonna be called load underscore bronze, and for the silver, load underscore silver. So those are currently the rules for the stored procedure. So this is how I do it usually in my projects. Alright my friends, so with that we have a solid naming conventions for our projects. So this is done, and now the next step is that we're gonna go to Git and you will create a brand new repository and we're gonna prepare its structure. So let's go. Alright, so now we come to as well important step in any project, and that's by creating the Git repository. So if you are new to Git, don't worry about it. It is simpler than it sounds. So it's all about to have a safe place where you can put your codes that you are developing, and you will have the possibility to track everything happened to the codes. And as well, you can use it in order to collaborate with your team, and if something goes wrong, you can always roll back. And the best part here, once you are done with the project, you can share your repository as a part of your portfolio. And it is really amazing thing if you are applying for a job by showcasing your skills that you have built a data warehouse by using well-documented Git repository. So now let's go and create the repository of the project. Now we are at the overview of our account. So the first thing that you have to do is to go to the repositories over here, and then we're gonna go to this green button and click on new. The first thing that we have to do is to give the repository name. So let's call it SQL Data Warehouse Project. And then here we can go and give it a description. So for example, I'm saying building a modern data warehouse with SQL Server. Now the next option, whether you want to make it public and private, I'm gonna leave it as a public. And then let's go and add here a README file. And then here about the license, we can go over here and select the MIT. MIT license gives everyone the freedom of using and modifying your code. Okay, so I think I'm happy with the setup. Let's go and create the repository. And with that, we have our brand new repository. Now, the next step that I usually do is to create the structure of the repository. And usually, I always follow the same patterns in any project. So here we need few folders in order to put our files, right? So what I usually do, I go over here to add file, create a new file, and I start creating the structure over here. So the first thing is that we need datasets, then slash, and with that, the repository can understand this is a folder, not a file. And then you can go and add anything. Like here, placeholder, just an empty file. This just gonna help me to create the folders. So let's go and commit. So commit the changes. And now if you go back to the main project, you can see now we have a folder called datasets. So now I'm gonna go and keep creating stuff. So I will go and create the documents, placeholder, commit the changes, and then I'm gonna go and create the scripts, placeholder. And the final one, what I usually add, is the tests. Something like this. So with that, as you can see now, we have the main folders of our repository. Now what I usually do, the next step is that I'm gonna go and edit the main readme. So you can see it over here as well. So what we're gonna do, we're gonna go inside the readme, and then we're gonna go to the edit button here, and we're gonna start writing the main information about our project. This is really depend on your style, so you can go and add whatever you want. This is the main page of your repository. And now as you can see, the file name here is .md. It stands for Markdown. It is just an easy and friendly format in order to write a text. So if you have like documentations, you are writing a text, it is a really nice format in order to organize it, structure it, and it is very friendly. So what I'm gonna do at the start, I'm gonna give a few description about the project. So we have the main title, and then we have like a welcome message and what this repository is about. And in the next section, maybe we can start with the project requirements, and then maybe at the end you can say a few words about the licensing and a few words about you. So as you can see, it's like the homepage of the project and the repository. So once you are done, we're gonna go and commit the changes. And now if you go to the main page of the repository, you can see always the folder and files at the start, and then below it it, we're gonna see the informations from the README. So again, here we have the welcome statement, and then the project's requirements, and at the end we have the licensing and about me. So my friends, that's it. We have now a repository, and we have now the main structure of the projects. And through the projects, as we are building the data warehouse, we're gonna go and commit all our work in this repository. Nice, right? Alright, so with that we have now your repository ready, and as we go in the projects we will be adding stuff to it. So this step is done, and now the last step, finally we're gonna go to the SQL server and we're gonna write our first script where we're gonna create a database and schemas. Now the first step is we have to go and create a brand new database. So now in order to do that, first we have to switch to the database master. So you can do it like this, use master and semicolon. And if you go and execute it, now we are switched to the master database. It is a system database in SQL Server where you can go and create other databases. And you can see here from the toolbar that we are now logged into the master database. Now the next step, we have to go and create our new database. So we're gonna say create database, and you can call it whatever you want. So I'm gonna go with data warehouse, semicolon. Let's go and execute it. And with that, we have created our database. Let's go and check it from the Object Explorer. Let's go and refresh, and you can see our new data warehouse. This is our new database. Awesome, right? Now to the next step, we're gonna go and switch to the new database. So we're gonna say use data warehouse and semicolon. So let's go and switch to it, and you can see now we are logged into the data warehouse database, and now we can go and start building stuff inside this data warehouse. So now the first step that I usually do is I go and start creating the schemas. So what is a schema? Think about it, it's like a folder or a container that helps you to keep things organized. So now, as we decided in the architecture, we have 3 layers, bronze, silver, gold, and now we're gonna go and create for each layer a schema. So let's go and do that. We're gonna start with the first one, create schema, and the first one is bronze. So let's do it like this, and a semicolon. Let's go and create the first schema. Nice, so we have a new schema. Let's go to our database, and then in order to check the schemas, we go to the security and then to the schemas over here. And as you can see, we have the bronze, and if you don't find it, you have to go and refresh the whole schemas, and then you will find the new schema. Great, so now we have the first schema. Now what we're gonna do, we're gonna go and create the others too. So I'm just gonna go and duplicate it. So the next one gonna be the silver, and the third one gonna be the gold. So let's go and execute those two together. We will get an error, and that's because we are not having the go in between. So after each command, let's have a go. And now if I highlight the silver and gold and then execute, it will be working. The go in SQL, it is like separator. So it tells SQL first execute completely the first command before go to the next one. So it is just separator. Now let's go to our schemas, refresh, and now we can see as well we have the gold and the silver. So with this, we have now a database, we have the 3 layers, and we can start developing each layer individually. Okay, so now let's go and commit our work in the Git. So now since it is a script and code, we're gonna go to the folder scripts over here, and then we're gonna go and add a new file. Let's call it init database.sql, and now we're gonna go and paste our code over here. So now I have done few modifications, like for example, before we create the database, we have to check whether the database exists. This is an important step if you are recreating the database. Otherwise, if you don't do that, you will get an error where SQL gonna say the database already exists. So first it is checking whether the database exists, then it drops it. I have added few comments, like here we are saying creating the data warehouse, creating the schemas, and now we have a very important step. We have to go and add a header comment at the start of each script. To be honest, after 3 months from now, you will not be remembering all the details of this script, and adding a comment like this, it is like a sticky note for you later once you visit this script again. And it is as well very important for the other developers in the team, because each time you open a script, the first question gonna be, what is the purpose of this script? Because if you or anyone in the team open the file, the first question gonna be, what is the purpose of this script? Why we are doing this stuff? So as you can see here, we have a comment saying, this script creates a new data warehouse after checking if it already exists. If the database exists, it's gonna drop it and recreate it. And additionally, it's gonna go and create 3 schemas, bronze, silver, gold. So with that, it gives gives clarity what this script is about, and it makes everyone's life easier. Now, the second reason why this is very important to add is that you can add warnings, and especially for this script, it is very important to add these notes, because if you run this script, what's gonna happen, it's gonna go and destroy the whole database. Imagine someone open this script and run it. Imagine an admin open this script and run it in your database. Everything gonna be destroyed and all the data will be lost, and this can be a disaster if you don't have any backup. So with that, we have nice header comments, and we have added few comments in our code, and now we are ready to commit our code. So let's go and commit it. And now we have our script in the Git as well. And of course, if you are doing any modifications, make sure to update the changes in the Git. Okay, my friends, so with that we have an empty database and schemas, and we are done with this task, and as well we are done with the whole epic. So we have completed the project initialization, and now we're gonna go to the interesting stuff. We will go and build the bronze layer. So now the first task is to analyze the source systems. So let's go. Alright, so now the big question is how to build the bronze layer. So first thing first, we do analyzing. As you are developing anything, you don't immediately start writing a code. So before we start coding the bronze layer, what we usually do is we have to understand the source system. So what I usually do, I make an interview with the source system experts and ask them many questions in order to understand the nature of the source system that I'm connecting to the data warehouse. And once you know the source systems, then we can start coding. And the main focus here is to do the data ingestion. So that means we have to find a way on how to load the data from the source into the data warehouse. So it's like we are building a bridge between the source and our target system, the data warehouse. And once we have the code ready, the next step is we have to do data validation. So here comes the quality control. It is very important in the bronze layer to check the data completeness. So that means we have to compare the number of records between the source system and the bronze layer, just to make sure we are not losing any data in between. And another check that we will be doing is the schema checks, and that's to make sure that the data is placed on the right position. And finally, we don't have to forget about documentation and committing our work in the Git. So this is the process that we're gonna follow to build the bronze layer. Alright, my friends, so now before connecting any source systems to our data warehouse, we have to make a very important step is to understand the sources. So how I usually do it, I set up a meeting with the source systems experts in order to interview them, to ask them a lot of stuff about the source. And gaining this knowledge is very important because asking the right question will help you to design the correct scripts in order to extract the data and to avoid a lot of mistakes and challenges. And now I'm going to show you the most common questions that I usually ask before connecting anything. Okay, so we start first by understanding the business context and the ownership. So I would like to understand the story behind the data. I would like to understand who is responsible for the data, which IT departments, and so on. And then it's nice to understand as well what business process it supports. Does it support the customer transactions, the supply chain, logistics, or maybe finance reporting? So with that, you're gonna understand the importance of your data. And then I ask about the system and data documentation. So having documentations from the source is your learning materials about your data, and it's gonna save you a lot of time later when you are working and designing maybe new data models. And as well, I would like always to understand the data model for the source system, and if they have like descriptions of the columns and the tables, it's gonna be nice to have the data catalog. This can help me a lot in the data warehouse, how I'm gonna go and join the tables together. So with that, you get a solid foundations about the business context, the processes, and the ownership of the data. And now in the next step, we're gonna start talking about the technicality. So I would like to understand the architecture and as well the technology stack. So the first question that I usually ask is how the source system is storing the data. Do we have the data on the on-prem like in SQL Server, Oracle, or is it in the cloud like Azure, AWS, and so on? And then once we understand that, then we can discuss what are the integration capabilities, like how I'm gonna go and get the data. Do the source system offer APIs, maybe Kafka, or they have only like file extractions? or they're gonna give you like a direct connection to the database. So once you understand the technology that you're gonna use in order to extract the data, then we're gonna deep dive into more technical questions. And here we can understand how to extract the data from the source system and then load it into the data warehouse. So the first thing that we have to discuss with the experts, can we do an incremental load or a full load? And then after that, we're gonna discuss the data scope, the historizations. Do we need all data? Do we need only maybe 10 years of the data? Are there histories already in the source system, or should we build it in the data warehouse, and so on? And then we're gonna go and discuss what is the expected size of the extracts. Are we talking here about megabytes, gigabytes, terabytes? And this is very important to understand whether we have the right tools and platform to connect the source system. And then I try to understand whether there are any data volume limitations. Like if you have some old source systems, they might struggle a lot with performance and so on. So if you have like an ETL that is extracting large amount of data, you might bring the performance down of the source system. So that's why you have to try to understand whether there are any limitations for your extracts, and as well other aspects that might impact the performance of the source system. This is very important. If they give you an access to the database, you have to be responsible that you are not bringing the performance of the database down. And of course, very important question is to ask about the authentication and the authorization. Like how are you going to go and access the data in the source system? Do you need any tokens, keys, password, and so on? So those are the questions that you have to ask if you are connecting a new source system to the data warehouse. And once you have the answers for those questions, you can proceed with the next steps to connect the sources to the data warehouse. Alright my friends, so with that you have learned how to analyze new source systems that you want to connect to your data warehouse. So this step is done, and now we're gonna go back to coding, where we're gonna write scripts in order to do the data ingestion from the CSV files to the bronze layer. And let's have a quick look again to our bronze layer specifications. So we just have to load the data from the sources to the data warehouse. We're gonna build tables in the bronze layer. We are doing a full load. So that means we are truncating and then inserting the data. There will be no data transformations at all in the bronze layer. And as well, we will not be creating any data model. So this is the specifications of the bronze layer. Alright, now in order to create the DDL script for the bronze layer, creating the tables of the bronze, we have to understand the metadata, the structure, the schema of the incoming data. And here either you ask the technical experts from the source system about these informations, or you can go and explore the incoming data and try to define the structure of your tables. So now what we're gonna do, we're gonna start with the first source system, the CRM. So let's go inside it, and we're gonna start with the first table, the customer info. Now if you open the file and check the data inside it, you see we have a header information, and that is very good because now we have the names of the columns that are coming from the source, and from the content you can define, of course, the data types. So let's go and do that. First we're going to say create table, and then we have to define the layer. It's going to be the bronze, and now very important, we have to follow the naming convention. So we start with the name of the source system. It is the CRM underscore, and then after that the table name from the source system. So it's going to be the cost underscore info. So this is the name of our first table in the bronze layer. And then the next step, we have to go and define, of course, the columns. And here again, the column names in the bronze layer are going to be one-to-one, exactly like the source system. So the first one going to be the ID, and I will go with the data type integer. Then the next one going to be the key in varchar, and the length I will go with 50. Last one gonna be the create date. It's gonna be a date. So with that we have covered all the columns available from the source system. So let's go and check. And yes, the last one is the create date. So that's it for the first table. Now a semicolon, of course, at the end. Let's go and execute it. And now we're gonna go to the Object Explorer over here, refresh, and we can see the first table inside our data warehouse. Amazing, right? So now next what you have to do is to go and create a DDL statement for each file for those two systems. So for the CRM, we need 3 DDLs, and as well for the other system, the ERP, we have as well to create 3 DDLs for the 3 files. So at the end, we're gonna have in the bronze layer 6 tables, 6 DDLs. So now pause the video, go create those DDLs. I will be doing the same as well, and we will see you soon. Alright, so now I hope you have created all those details. I'm going to show you what I have just created. So the second table in the source CRM, we have the product informations, and the third one is the sales details. Then we go to the second system, and here we make sure that we are following the naming convention. So first the source system, ERB, and then the table name. So the second system was really easy. You can see we have only here like 2 columns, and for the customers like only 3, and for the categories only 4 columns. Alright, so after defining those stuff, of course we have to go and execute them. So let's go and do that. And then we go to the Object Explorer over here, refresh the tables, and with that you can see we have 6 empty tables in the bronze layer, and with that we have all the tables from the 2 source systems inside our database, but still we don't have any data. And you can see our naming convention is really nice. You see the first 3 tables comes from the CRM source system, and then the other 3 comes from the ERB. So we can see in the bronze layer the things are really splitted nicely, and you can identify quickly which table belongs to which source system. Now there is something else that I usually add to the DDL script, is to check whether the table exists before creating. So for example, let's say that you are renaming or you would like to change the data type of specific field. If you just go and run this query, you will get an error because the database is going to say we have already this table. So in other databases you can say create or replace table, but in the SQL server you have to go and build a TSQL logic. So it is very simple. First we have to go and check whether the object exists in the database. So we say if object ID, and then we have to go and specify the table name. So let's go and copy the whole thing over here and make sure you get exactly the same name as the table name. So there is here like space. I'm just going to go and remove it. And then we're going to go and define the object type. So it's going to be the U. It stands for user. It is the user defined tables. So if this table is not null, so that means the database did find this object in the database. So what can happen? We say go and drop the table. So the whole thing again and semicolon. So again, if the table exists in the database is not null, then go and drop the table, and after that go and create it. So now if you go and highlight the whole thing and then execute it, it will be working. So first drop the table if it exists, then go and create the table from scratch. Now what you have to do is to go and add this check before creating any table inside our database. So it's gonna be the same thing for the next table and so on. I went and added all those checks for each table. And what can happen if I go and execute the whole thing, it's gonna work. So with that, I'm recreating all the tables in the bronze layer from the scratch. Now the methods that we're going to use in order to load the data from the source to the data warehouse is the bulk inserts. Bulk insert is a method of loading massive amount of data very quickly from files like CSV files or maybe a text file directly into a database. It is not like the classical normal inserts where it's going to go and insert the data row by row, but instead the bulk insert is one operation that's going to load all the data in one go into the database, and that's what makes it very fast. So let's go and use this method. Okay, so now let's start writing the script in order to load the first table in the source CRM. So we're gonna go and load the table customer info from the CSV file to the database table. So the syntax is very simple. We're gonna start with saying bulk insert. So with that, SQL understand we are doing not a normal insert, we are doing a bulk insert. And then we have to go and specify the table name. So it is bronze.crm cost info. So now we have to specify the full location of the file that we are trying to load in this table. So now what we have to do is to go and get the path where the file is stored. So I'm gonna go and copy the whole path and then add it to the bulk insert exactly like where the data exists. So for me it is in C SQL data warehouse project dataset in the source CRM, and then I have to specify the file name. So it's gonna be the cost_info.csv. You have to get it exactly like the path of your files, otherwise it will not be working. So after the path, now we come to the with clause. Now we have to tell the SQL server how to handle our file. So here comes the specifications. There is a lot of stuff that we can define. So let's start with with the very important one is the row header. Now if you check the content of our files, you can see always the first row includes the header information of the file. So those informations are actually not the data, it's just the column names. The actual data starts from the second row, and we have to tell the database about this information. So we're gonna say first row is actually the second row. So with that, we are telling SQL to skip the first row in the file. We don't need to load those informations because we have already defined the structure of our table. So this is the first specifications. The next one, which is as well very important in loading any CSV file, is the separator between fields, the delimiter between fields. So it really depends on the file structure that you are getting from the source. As you can see, all those values are splitted with a comma, and we call this comma as a file separator or a delimiter. And I saw a lot of different CSVs, like sometimes they use a semicolon or a pipe or a special character like a hash and so on. So you have to understand how the values are splitted, and in this file it's splitted by the comma, and we have to tell SQL about this info. It's very important. So we're gonna say field terminator, and then we're gonna say it is the comma. And basically those two informations are very important for SQL in order to be able to read your CSV file. Now there are like many different options that you can go and add. For example, tab lock. It is an option in order to improve the performance where you are locking the entire table during loading it. So as SQL is loading the data to this table, it's gonna go and lock the whole table. So that's it for now. I'm just gonna go and add the semicolon, and let's go and insert the data from the file inside our bronze table. Let's execute it, and now you can see SQL did insert around 80,000 rows inside our table. So it is working. We just loaded the file into our database, but now it is not enough to just write the script. You have to test the quality of your bronze table, especially if you are working with files. So let's go and just do a simple select. So from our new table, and let's run it. So now the first thing that I check is, do we have data like in each column? Well, yes, as you can see, we have data. And the second thing is, do we have the data in the correct column? This is very critical as you are loading the data from a file to a database. Do we have the data in the correct column? So for example, here we have the first name, which of course makes sense, and here we have the last name. But what could happen, and this mistakes happens a lot, is that you find the first name informations inside the key, and as well you see the last name inside the first name, and the status inside the last name. So there is like shifting of the data, and this data engineering mistake is very common if you are working with CSV files. And there are like different reasons why it happens. Maybe the definition of your table is wrong, or the field separator is wrong. Maybe it's not a comma, it's something else, or the separator is a bad separator, because sometimes maybe in the keys or in the first name there is a comma, and the SQL is not able to split the data correctly. So the quality of the CSV file is not really good. And there are many different reasons why you are not getting the data in the correct column. But for now, everything looks fine for us. And the next step is that I go and count the rows inside this table. So let's go and select that. So we can see we have 18,493. And now what we can do, we can go to our CSV file and check how many rows do we have inside this file. And as you can see, we have 18,494. We are almost there. There is like one extra row inside the file, and that's because of the header. The first header information is not loaded inside our table, and that's why always in our tables we're gonna have one less row than the original files. So everything looks nice, and we have done this step correctly. Now if I go and run it again, what's gonna happen? We will get duplicates inside the bronze layer. So now we have loaded the file like twice inside the same table, which is not really correct. The method that we have discussed is first to make the table empty and then load, truncate and then insert. In order to do that, before the bulk insert, what we're gonna do, we're gonna say truncate table, and then we're gonna have our table, and that's it with a semicolon. So now what we are doing is, first we are making the table empty, and then we start loading from the scratch. We are loading the whole content of the file inside the table, and this is what we call full load. So now let's go and mark everything together and execute. And again, if you go and check the content of the table, you can see we have only 18,000 rows. Let's go and run it again. The count of the bronze layer, you can see we still have the 18,000. So each time you run this script now, we are refreshing the table customer info from the file into the database table. So we are refreshing the bronze layer table. So that means if there is like now any changes in the file, it will be loaded to the table. So this is how you do a full load in the bronze layer, by truncating the table and then doing the insert. And now of course what we have to do is to pause the video and go and write the same script for all 6 files. So let's go and do that. Okay, back. So I hope that you have as well written all those scripts. So I have the 3 tables in order to load the first source system, and then 3 sections in order to load the second source system. And as I'm writing those scripts, make sure to have the correct path. So for the second source system, you have to go and change the path for the other folder. And as well, don't forget the table name on the bronze layer is different from the file name, because we start always with the source system name. With the files, we don't have that. So now I think I have everything is ready. So let's go and execute the whole thing. Perfect, awesome. So everything is working. Let me check the messages. So we can see from the message how many rows are inserted in each table. And now of course the task is to go through each table and check the content. So that means now we have really nice script in order to load the bronze layer. And we will use this script in daily basis. Every day we have to run it in order to get a new content to the data warehouse. And as we learned before, if you have like a script of SQL that is frequently used, what we can do, we can go and create a stored procedure from those scripts. So let's go and do that. It's going to be very simple. We're going to go over here and say create or alter procedure. And now we have to define the name of the stored procedure. I'm going to go and put it in the schema bronze because it belongs to the bronze layer. So then we're going to go and follow the naming convention. The stored procedure starts with load underscore and then the bronze layer. So that's it about the name. And then very important, we have to define the begin and as well the end of our SQL statements. So here is the begin and let's go to the end and say this is the end, and then let's go highlight everything in between and give it one push with tab. So with that, it is easier to read. So now next what we're going to do, we're going to go and execute it. So let's go and create this stored procedure. And now if you want to go and check your stored procedure, you go to the database and then we have here a folder called programmability. And then inside it we have stored procedure. So if you go and refresh, you will see our new stored procedure. Let's go and test it. So I'm going to go and have a new query. And what we're going to do, we're going to say execute bronze.load bronze. So let's go and execute it. And with that, we have just loaded completely the bronze layer. So as you can see, SQL did go and insert all the data from the files to the bronze layer. It is way easier than each time running those scripts, of course. Alright, so now the next step is that, as you can see, the output message, it is really not having a lot of informations. The message of your ETL stored procedure, it will not be really clear. So that's why if you are writing an ETL script, always take care of the messaging of your code. So let me show you a nice design. Let's go back to our stored procedure. So now what we can do, we can go and divide the message based on our code. So now we can start with the message, for example, over here, let's say print, and we say what we are doing with this stored procedure. We are loading the bronze layer. So this is the main message, the most important one. And we can go and play with the separators like this. So we can say print, and now we can go and add some nice separators, like for example, the equals at the start and at the end, just to have like a section. So this is just a nice message at the start. So now by looking to our code, we can see that our code is split into 2 sections. The first section, we are loading all the tables from the source system CRM, and the second section is loading the tables from the ERP. So we can split the prints by the source system. So let's go and do that. So we're going to say print, and we're going to say loading CRM tables. This is for the first section. And then we can go and add some nice separators like the one, let's take the minus. And of course, don't forget to add semicolons like me. So we can have semicolon for each print. Same thing over here. I will go and copy the whole thing because we're going to have it at the start and as well at the end. Let's go copy the whole thing for the second section. So for the ERP, it starts over here and we're gonna have it like this, and we're gonna call it loading ERP. So with that, in the output, we can see nice separation between loading each source system. Now we go to the next step where we go and add like a print for each action. So for example, here we are truncating the table. So we say print, and now what we can do, we can go and add 2 arrows, and we say what we are doing. So we are truncating the table, and then we can go and add the table name in the message as well. So this is the first action that we are doing, and we can go and add another print for inserting the data. So we can say inserting data into, and then we have the table name. So with that, in the output, we can understand what SQL is doing. So let's go and repeat this for all other tables. Okay, so I just added all those prints, and don't forget the semicolon at the end. So I would say let's go and execute it and check the output. So let's go and do that, and then maybe at the start, just to have quick output, execute our stored procedure like this. So let's see. Now if you check the output, you can see things are more organized than before. So at the start we are reading, okay, we are loading the bronze layer. Now first we are loading the source system CRM, and then the second section is for the ERP, and we can see the actions. So we are truncating, inserting for each table, and as well the same thing for the second source. So as you can see, it is nice and cosmetic, but it's very important as you are debugging any errors. And speaking of errors, we have to go and handle the errors in our stored procedure. So let's go and do that. It's gonna be the first thing that we do. We say begin try, and then we go to the end of our script, and we say before the last end, we say end try, and then the next thing we have to add the catch. So we're gonna say begin catch and end catch. So now first let's go and organize our code. I'm gonna take the whole code and give it one more push, and as well the begin try, so it is more organized. And as you know, the try and catch, SQL gonna go and execute the try, and if there is like any errors during executing this script, the second section gonna be executed. So the catch will be executed only if the SQL failed to run the try. So now what we have to do is to go and define for SQL what to do if there is like an error in your code. And here we can do multiple stuff, like maybe creating a logging tables and add the messages inside this table, or we can go and add some nice messaging to the output. Like for example, we can go and add like a section again over here. So again, some equals, and we can go and repeat it over here, and then add some content in between. So we can start with something like to say error occurred during loading bronze layer. And then we can go and add many stuff, like for example, we can go and add the error message. And here we can go and call the function error message. And we can go and add as well, for example, the error number. So error number. And of course, the output of this is going to be in number, but the error message here is a text. So we have to go and change the data type. So we're going to do a cast as in varchar, like this. And then there is like many functions that you can add to the output, like for example, the error state and so on. So you can design what can happen if there is an error in the ETL. Now, what else is very important in each ETL process is to add the duration of each like step. So for example, I would like to understand how long it takes to load this table over here. But looking to the output, I don't have any information how long it's taking to load my tables. And this is very important because as you are building like a big data warehouse, the ETL process is going to take a long time, and you would like to understand where is the issue, where is the bottleneck, which table is consuming a lot of time to be loaded. So that's why we have to add those informations as well to the output, or even maybe to protocol it in a table. So let's go and add as well this step. So we're going to go to the start, and now in order to calculate the duration, you need the starting time and the end time. So we have to understand when we started loaded and when we ended loading the table. So now the first thing is we have to go and declare the variables. So we're going to say declare, and then let's make one called start time, and the data type of this is going to be the date time. I need exactly the second when it started, and then another one for the end time. So another variable, end time, and as well the same thing, date time. So with that, we have declared the variables, and the next step is to go and use them. So now let's go to the first table, to the customer info, and at the start, we're going to say set start time equal to get date. So we will get the exact time when we start loading this table. and then let's go and copy the whole thing and go to the end of loading over here. So we're gonna say set this time, the end time, equal as well to the get date. So with that, now we have the values of when we start loading this table and when we completed loading the table. And now the next step is we have to go and print the duration, those informations. So over here, we can go and say print, and we can go and have as again the same design. So 2 arrows, and we can say very simply load duration, and then double points and space. And now what we have to do is to calculate the duration, and we can do that using the date and time function dateDiff in order to find the interval between 2 dates. So we're gonna say plus over here and then use dateDiff, and here we have to define 3 arguments. First one is the unit, so here you can define second, minute, hours, and so on. So we're gonna go with the second, and then we're gonna define the start of the interval. It's gonna be the start time, and then the last argument is gonna be the end of the boundary. It's gonna be the end time. And now of course the output of this is gonna be in number. That's why we have to go and cast it. So we're gonna say cast as in varchar, and then we're gonna close it like this, and maybe at the end we're gonna say plus space seconds in order to have a nice message. So again, what we have done, we have declared the 2 variables and we are using them. At the start, we are getting the current date and time, and at the end of loading the table, we are getting the current date and time, and then we are finding the differences between them in order to get the load duration. And in this case, we are just printing this information. And now we can go, of course, and add some nice separator between each table. So I'm gonna go and do it like this. Just few minuses, not a lot of stuff. So now what we have to do is to go and add this mechanism for each table in order to measure the speed of the ETL for each one of them. Okay, so now I have added all those configurations for each table, and let's go and run the whole thing now. So let's go and edit the stored procedure, this, and we're gonna go and run it. So let's go and execute. So now as you can see, we have here one more info about the load durations, and it is everywhere. I can see we have 0 seconds, and that's because it is super fast of loading those informations. We are doing everything locally at PC, so loading the data from files to database is gonna be mega fast. But of course, in real projects, you have like different servers and networking between them, and you have millions of rows in the tables. Of course, the duration gonna be not like 0 seconds. Things gonna be slower, and now you can see easily how long it takes to load each of your tables. And now, of course, what is very interesting is to understand how long it takes to load the whole bronze layer. So now your task is as well to print at the end informations about the whole batch, how long it took to load the bronze layer. Okay, I hope we are done. Now I have done it like this. We have to define 2 new variables. So the start time of the batch and the end time of the batch. And the first step in the stored procedure is to get the date and time informations for the first variable. And exactly at the end, the last thing that we do in the stored procedure, we're gonna go and get the date and time informations for the end time. So we say again, set get date for the batch end time. And then all what you have to do is to go and print a message. So we are saying loading bronze layer is completed, and then we are printing total load duration, and the same thing with a date difference between the batch start time and the end time, and we are calculating the seconds and so on. So now what you have to do is to go and execute the whole thing. So let's go and refresh the definition of the stored procedure, and then let's go and execute it. So in the output, we have to go to the last message, and we can see loading bronze layer is completed, and the total load duration is as well 0 seconds, because the execution time is less than 1 second. So with that, you are getting now a feeling about how to build an ETL process. So as you can see, the data engineering is not all about how to load the data. It's how to engineer the whole pipeline, how to measure the speed of loading the data, what can happen if there is like an error, and to print each step in your ETL process and make everything organized and cleared in the output and maybe in the logging, just to make debugging and optimizing the performance way easier. And there is like a lot of things that we can add. We can add the quality measures and stuff. So we can add many stuff to our ETL scripts to make our data warehouse professional. Alright my friends, so with that we have developed a code in order to load the bronze layer, and we have tested that as well. And now in the next step we're gonna go back to Draw.io because we want to draw a diagram about the data flow. So let's go. So now what is a data flow diagram? We're gonna draw a simple visual in order to map the flow of your data, where it comes from and where it ends up. So we want just to make clear how the data flows through different layers of your project. And that's help us to create something called the data lineage. And this is really nice, especially if you are analyzing an issue. So if you have like multiple layers and you don't have a real data lineage or flow, it's gonna be really hard to analyze the scripts in order to understand the origin of the data. And having this diagram gonna improve the process of finding issues. So now let's go and create one. Okay, so now back to Draw.io, and we're gonna go and build the flow diagram. So we're gonna start first with the source system. So let's build the layer. I'm gonna go and remove the fill, dot it, and then we're gonna go and add like a box saying sources, and we're gonna put it over here, increase the size 24, and as well without any lines. Now what do we have inside the sources? We have like folder and files. So let's go and search for a folder icon. I'm gonna go and take this one over here and say you are the CRM, and we can as well increase the size. And we have another source, we have the ERP. Okay, so this is the first layer. Let's go and now have the bronze layer. So we're gonna go and grab another box, and we're gonna go and make the coloring like this, and instead of auto, maybe take the hatch, maybe something like this, whatever, you know. So rounded, and then we can go and put on top of it like the title. So we can say you are the bronze layer, and increase as well the size of the font. So now what we're gonna do, we're gonna go and add boxes for each table that we have in the bronze layer. So for example, we have the sales details. We can go and make it a little bit smaller, so maybe 16 and not bold. And we have other two tables from the CRM. We have the customer info and as well the product info. So those are the three tables that comes from the CRM. And now what we're gonna do, we're gonna go and connect now the source CRM with those three tables. So what we're gonna do, we're gonna go to the folder and start making arrows from the folder to the bronze layer like this. And now we have to do the same thing for the ERP source. So as you can see, the data flow diagram shows us in one picture the data lineage between the two layers. So here we can see easily those three tables actually comes from the CRM, and as well those three tables in the bronze layer are coming from the ERP. I understand if we have like a lot of tables, it's gonna be a huge mess, but if you have like small or medium data warehouse, building those diagrams gonna make things really easier to understand how everything is flowing from the sources into the different layers in your data warehouse. Alright, so with that we have the first version of the data flow. So this step is done, and the final step is to commit our code in the Git repo. Okay, so now let's go and commit our work. Since it is scripts, we're gonna go to the folder scripts, and here we're gonna have like scripts for the bronze, silver, and gold. That's why maybe it makes sense to create a folder for each layer. So let's go and start creating the bronze folder. So I'm gonna go and create a new file, and then I'm gonna say bronze / and then we can have the DDL script of the bronze layer .sql. So now I'm gonna go and paste the DDL codes that we have created. So those 6 tables, and as usual at the start we have a comment where we are explaining the purpose of this script. So we are saying this script creates tables in the bronze schema, and by running this script you are redefining the DDL structure of the bronze tables. So let's have it like that, and I'm gonna go and commit the changes. Alright, so now as you can see inside the scripts we have a folder called bronze, and inside it we have the DDL script for the bronze layer. And as well in the bronze layer we're gonna go and put our storage procedure. So we're gonna go and create a new file. Let's call it proc load bronze.sql, and then let's go and paste our script. And as usual I have put it at the start an explanation about the stored procedure. So we are saying this stored procedure gonna go and load the data from the CSV files into the bronze schema. So it's gonna go and truncate first the tables and then do bulk inserts. And about the parameters, this stored procedure does not accept any parameter or return any values. And here a quick example how to execute it. Alright, so I think I'm happy with that. So let's go and commit it. Alright my friends, so with that we have committed our code into the Git, and with that we are done building the bronze layer. So the whole epic is done. Now we're gonna go to the next one. This one gonna be more advanced than the bronze layer because there will be a lot of struggle with cleaning the data and so on. So we're gonna start with the first task where we're gonna analyze and explore the data in the source systems. So let's go. Okay, so now we're gonna start with the big question. How to build the server layer? What is the process? Okay, as usual, first things first, we have to analyze. And now the task before building anything in the server layer, we have to go and explore the data in order to understand the content of our sources. Once we have it, what we're gonna do, we will be starting coding. And here the transformation that we're gonna do is data cleansing. This is usually a process that takes really long time, and I usually do it in 3 steps. The first step is to check first the data quality issues that we have in the bronze layer. So before writing any data transformations, first we have to understand what are the issues, and only then I start writing data transformations in order to fix all those quality issues that we have in the bronze. And the last step, once I have clean results, what we're gonna do, we're gonna go and insert it into the server layer. And those are the 3 phases that we will be doing as we are writing the code for the server layer. And the third step, once we have all the data in the server layer, we have to make sure that the data is now correct and we don't have any quality issues anymore. And if you find any issues, of course, what you're gonna do, we're gonna go back to coding, we're gonna do the data cleansing and again check. So it is like a cycle between validating and coding. Once the quality of the server layer is good, we cannot skip the last phase where we're gonna document and commit our work in the Git. And here we're gonna have 2 new documentations. We're gonna build the data flow diagram and as well the data integration diagram after we understood the relationship between the sources from the first step. So this is the process and this is how we're gonna build the server layer. So now exploring the data in the bronze layer. So why it is very important? Because understanding the data, it is the key to make smart decisions in the server layer. It was not the focus in the bronze layer to understand the content of the data at all. We focused only how to get the data to the data warehouse. So that's why we have now to take a moment in order to explore and understand the tables and as well how to connect them. What are the relationship between these tables? And it is very important as you are learning about a new source system is to create like some kind of documentation. So now let's go and explore the sources. Okay, so now let's go and explore them one by one. We can start with the first one from the CRM. We have the customer info. So right click on it and say select top 1000 rows. And this is of course important if you have like a lot of data. Don't go and explore millions of rows. Always limit your queries. So for example, here we are using the top 1000 just to make sure that you are not impacting the system with your queries. So now let's have a look to the content of this table. So we can see that we have here customer informations. So we have an ID, we have a key for the customer, we have first name, last name, marital status, gender, and the creation date of the customer. So simply this is a table for the customer information and a lot of details for the customers. And here we have like 2 identifiers. One, it is like technical ID, and another one, it's like the customer number. So maybe we can use either the ID or the key in order to join it with other tables. So now what I usually do is to go and draw like a data model or let's say integration model just to document and visual what I am understanding. Because if you don't do that, you're gonna forget it after a while. So now we go and search for a shape. Let's search for a table and I'm gonna go and pick this one over here. So here we can go and change the style. For example, we can make it rounded or you can go make it sketch and so on. And we can go and change the color. So I'm gonna make it blue, then go to the text, make sure to select the whole thing and let's make it bigger, 26. And then what I'm gonna do for those items, I'm just gonna select them and go to arrange and maybe make it 40, something like this. So now what we're gonna do, we're gonna just go and put the table name. So this is the one that we are now learning about. And what I'm gonna do, I'm just gonna go and put here the primary key. I will not go and list all the informations. So the primary key was the ID and I will go and remove all those stuff. I don't need it. Now as you can see, the table name is not really friendly. So I can go and bring a text and put it here on top and say, this is the customer information, just to make it friendly and to not forget about it. And as well, I'm gonna increase the size to maybe 20, something like this. Okay, with that, we have our first table. And we're gonna go and keep exploring. So let's move to the second one. We're gonna take the product information, right click on it and select the top 1000 rows. I will just put it below the previous query it. Now by looking to this table, we can see we have product informations. So we have here a primary key for the product, and then we have like a key or let's say product number. And after that, we have the full name of the product costs, and then we have the product line, and then we have like start and end. Well, this is interesting to understand why we have start and ends. Let's have a look, for example, for those 3 rows. All of those 3 having the same key, but they have different IDs. So it is the same product, but with different costs. So for 2011, we have the cost of 12, then 2012, we have 14, and for the last year, 2013, we have 13. So it's like we have like a history for the changes. So this table not only holding the current informations of the product, but also history informations of the product. And that's why we have those two dates, start and end. Now let's go back and draw this information over here. So I'm just going to go and duplicate it. So the name of this table is going to be the BRD info. And let's go and give it like a short description. Current and history products information. Something like this, just to not forget that we have history in this table. And here we have as well the BRD ID. And there is like nothing that we can use in order to join those two tables. We don't have like a customer ID here, or in the other table we don't have any product ID. Okay, so that's it for this table. Let's jump to the third table and the last one in the CRM. So let's go and select. I just made the other queries as well short. So let's go and execute. So what do you have over here? We have a lot of informations about the order, the sales, and a lot of measures. Order number, we have the product key. So this is something that we can use in order to join it with the product table. We have the customer ID. We don't have the customer key. So here we have like ID and here we have key. So there is like two different ways on how to join tables. And then we have here like dates, the order date, the shipping date, the due date, and then we have the sales amount, the quantity, and the price. So this is like an event table. It is transactional table about the orders and sales, and it is great table in order to connect the customers with the products and as well with the orders. So let's document this new information that we have. So the table name is the sales details. So we can go and describe it like this: transactional records about sales and orders. And now we have to go and describe how we can connect this table to the other two. So we are not using the product ID, we are using the products key. And now we need a new column over here. So you can hold Control and Enter, or you can go over here and add a new row, and the other row is going to be the customer ID. So now for the customer ID, it is easy. We can go and grab an arrow in order to connect those two tables. But for the product key, we are not using the ID. So that's why I'm just going to go and remove this one and say product key. Let's have here again a check. So this is a product key. It's not a product ID. And if we go and check the old table, the products info, you can see we are using this key and not the primary key. So what we're going to do now, we will just go and link it like this and maybe switch those two tables. So I will put the customers below, just perfect. It looks nice. Okay, so let's keep moving. Let's go now to the other source system. We have the ARP, and the first one is ARP costs, and we have this cryptical name. Let's go and select the data. So now here it's small table and we have only three informations. So we have here something called CID, and then we have something, I think this is the birthday and the gender information. So we have here male, female, and so on. So it looks again like the customer informations, but here we have like extra data about the birthday. And now if you go and compare it to the customer table that we have from the other source system, let's go and query it. You can see the new table from the ARB don't have IDs. It has actually the customer number or the key. So we can go and join those two tables using the customer key. Let's go and document this information. So I will just go and copy paste and put it here on the right side. I will just go and change the color now, since we are now talking about different source system. And here the table name gonna be this one and the key called CID. Now in order to join this table with the customer info, we cannot join it with the customer ID. We need the customer keys. That's why here we have to go and add a new row. So Control Enter, and we're gonna say customer key, and then we have to go and make a nice arrow between those two keys. So we're gonna go and give it a description, customer information, and here we have the birth date. Okay, so now let's keep going. We're gonna go to the next one. We have the ERP location. Let's go and query this table. So what do you have over here? We have the CID again, and as you can see, we have country informations. And this is of course again the customer number, and we have only this information, the country. So let's go and document this information. This is the customer location. Table name gonna be like this, and we still have the same ID. So we have here still the customer ID, and we can go and join it using the customer key. And we have to give it the description, location of customers, And we can say here the country. Okay, so now let's go to the last table and explore it. We have the ERP PX catalog. So let's go and query those informations. So what do we have here? We have like an ID, a category, a subcategory, and the maintenance. Here we have like either yes and no. So by looking to this table, we have all the categories and the subcategories of the products. And here we have like special identifier for those informations. Now the question is how to join it. So I would like to join it actually with the product informations. So let's go and check those two tables together. Okay, so in the products, we don't have any ID for the categories, but we have these informations actually in the product key. So the first 5 characters of the product key is actually the category ID. So we can use this information over here in order to join it with the categories. So we can go and describe this information like this, and then we have to go and give it a name. And then here we have the ID, and the ID could be joined using the product key. So that means for the product information, we don't need at all the product ID, the primary key. All what we need is the product key or the product number. And what I would like to do is like to group those informations in a box. So let's go grab like any boxes here on the left side and make it bigger, and then make the edges a little bit smaller. Let's remove the fill and the line. I will make it dotted line. And then let's grab another box over here and say this is the CRM. And we can go and increase the size, maybe something like 40, smaller 35, bold, and change the color to blue and just place it here on top of this box. So with that, we can understand all those tables belongs to the source system CRM, and we can do the same stuff for the right side as well. Now, of course, we have to go and add the description here. So it's going to be the products categories. Alright, so with that we have now a clear understanding how the tables are connected to each others. We understand now the content of each table, and of course it can help us to clean up the data in the silver layer in order to prepare it. So as you can see, it is very important to take time understanding the structure of the tables, the relationship between them, before start writing any code. Alright, so with that we have now clear understanding about the sources, and with that we have as well created a data integration in the Draw.io. So with that we have more understanding about how to connect the sources. And now in the next 2 tasks we will go back to SQL, where we're gonna start checking the quality and as well doing a lot of data transformations. So let's go. Okay, so now let's have a quick look to the specifications of the silver layer. So the main objective, to have clean and standardized data. We have to prepare the data before going to the gold layer, and we will be building tables inside the silver layer. And the way of loading the data from the bronze to the silver is a full load. So that means we're gonna truncate and then insert. And here we're gonna have a lot of data transformations. So we're gonna clean the data, we're gonna bring normalizations, standardizations, we're gonna derive new columns. We will be doing as well data enrichment, so a lot of things to be done in the data transformation, but we will not be building any new data model. So those are the specifications, and we have to commit ourselves to this scope. Okay, so now building the DDL script for the silver layer gonna be way easier than the bronze, because the definition and the structure of each table in the silver gonna be identical to the bronze layer. We are not doing anything new, so all what you have to do is to take the DDL script from the bronze layer and just go and search and replace for the schema. I'm just using the Notepad++ for the scripts, so I'm gonna go over here and say replace the bronze dot with silver dot, and I'm gonna go and replace all. So with that, now all the DDL is targeting the schema silver layer, which is exactly what we need. Alright, now before we execute our new DDL script for the silver, we have to talk about something called the metadata columns. They are additional columns or fields that the data engineers add to each table that don't come directly from the source systems, but the data engineers use it in order to provide extra informations for each record. Like we can add a column called create date, is when the record was loaded, or an update date, when the record got updated, or we can add the source system in order to understand the origin of the data that we have. Or sometimes we can add the file location in order to understand the lineage from which file the data come from. Those are great tools if you have data issue in your data warehouse. If there is like corrupt data and so on, this can help you to track exactly where this issue happens and when. And as well, it is great in order to understand whether I have gap in my data especially if you are doing incremental loads. It is like putting labels on everything, and you will thank yourself later when you start using them in hard times as you have an issue in your data warehouse. So now back to our DDL scripts, and all what you have to do is to go and do the following. So for example, for the first table, I will go and add at the end one more extra column. So it starts with the prefix DWH as we have defined in the naming convention, and then underscore, let's have the create date, and the data type gonna be date time 2. And now what we can do is we can go and add a default value for it. I want the database to generate these informations automatically. We don't have to specify that in any ETL scripts. So which value? It's gonna be the get date. So each record going to be inserted in this table will get automatically a value from the current date and time. So now, as you can see, the naming convention, it is very important. All those columns comes from the source system, and only this one column comes from the data engineer of the data warehouse. Okay, so that's it. Let's go and repeat the same thing for all other tables. So I will just go and add this piece of information for each DDL. Alright, so I think that's it. All what you have to do is now to go and execute the whole DDL script for the server layer. Let's go and do that. Alright, perfect. There's no errors. Let's go and refresh the tables on the Object Explorer. And with that, as you can see, we have 6 tables for the server layer. It is identical to the bronze layer, but we have one extra column for the metadata. Alright, so now in the server layer, before we start writing any data transformations and cleansing, we have first to detect the quality issues in the bronze. Without knowing the issues, we cannot find the solution, right? We will explore first the quality issues, only then we start writing the transformation scripts. So let's go. Okay, so now what we're gonna do, we're gonna go through all the tables of the bronze layer, clean up the data, and then insert it to the server layer. So let's start with the first table, the first bronze table from the source CRM. So we're gonna go to the bronze CRM customer info. So let's go and query the data over here. Now, of course, before writing any data transformations, we have to go and detect and identify the quality issues of this table. So usually I start with the first check where we go and check the primary key. So we have to go and check whether there are nulls inside the primary key and whether there are duplicates. So now in order to detect the duplicates in the primary key, what we have to do is to go and aggregate the primary key. If we find any value in the primary key that exists more than once, that means it is not unique and we have duplicates in the table. So let's go and write a query for that. So what we're gonna do, we're gonna go with the customer ID, and then we're gonna go and count. And then we have to group up the data, so group by based on the primary key. And of course, we don't need all the results, we need only where we have an issue. So we're gonna say having count higher than 1. So we are interested in the values where the count is higher than 1. So let's go and execute it. Now, as you can see, we have issue in this table. We have duplicates because all those IDs exist more than 1 in the table, which is completely wrong. We should have the primary key unique. And you can see as well, we have 3 records where the primary key is empty, which is as well a bad thing. Now, there is an issue here. If we have only 1 null, it will not be here at the result. So what I'm gonna do, I'm gonna go over here and say or the primary key is null. Just in case if we have only 1 null, I'm still interested to see the results. So if I go and run it again, we'll get the same results. So this is a quality check that you can do on the table. And as you can see, it is not meeting the expectation. So that means we have to do something about it. So let's go and create a new query. So here what we're going to do, we can start writing the query that is doing the data transformation and the data cleansing. So let's start again by selecting the data. And execute it again. So now what I usually do, I go and focus on the issue. So for example, let's go and take one of those values and I focus on it before start writing the transformation. So we're gonna say where customer ID equal to this value. Alright, so now as you can see, we have here the issue where the ID exists 3 times, but actually we are interested only on one of them. So the question is how to pick one of those. Usually we search for a timestamp or date value to help us. So if you check the creation date over here, we can understand that this record, this one over here, is the newest one and the previous two are older than it. So that means if I have to go and pick one of those values, I would like to get the latest one because it holds the most fresh information. So what we have to do is we have to go and rank all those values based on the create date and only pick the highest one. So that means we need a ranking function, and for that in SQL we have the amazing window functions. So let's go and do that. We will use the function row number over and then partition by, and here we have to divide the table by the customer ID. So we're going to divide it by the customer ID, and in order now to rank those rows, we have to sort the data by something. So order by, and as we discussed, we want to sort the data by the creation date. So create date, and we're gonna sort it descending, so the highest first, then the lowest. So let's go and do that. And now we're gonna go and give it a name, flag, last. So now let's go and execute it. Now the data is sorted by the creation date, and you can see over here that this record is the number 1, then the one that is older is 2, and the oldest one is 3. Of course, we are interested in the rank number 1. Now let's go and remove the filter and check everything. So now if you have a look to the table, you can see that on the flag we have everywhere like 1, and that's because those primary keys exist only 1, but sometimes we will not have 1, we'll have 2, 3, and so on if there is like duplicates. We can go of course and do a double check. So let's go over here and say select star from this query. We're gonna say where flag last is equal to 1. So let's go and query it, and now we can see all the data that we don't need because they are causing duplicates in the primary key and they have like an old status. So what we're gonna do, we're gonna say equal to 1, and with that we guarantee that our primary key is unique and each value exists only once. So if I go and query it like this, you will see we will not find any duplicates inside our table, and we can go and check that of course. So let's go and check this primary key, and we're gonna say and customer ID equal to this value, and you can see it exists now only once, and we are getting the freshest data from this primary key. So with that we have defined like transformation in order to remove any duplicates. Okay, so now moving on to the next one. As you can see in our table we have a lot of values where they are like string values. Now for these string values we have to check the unwanted spaces. So now let's go and write the query that's gonna detect those unwanted spaces. So we're gonna say select this column, the first name, from our table bronze customer information. So let's go and query it. Now by just looking to the data, it's going to be really hard to find those unwanted spaces, especially if they are at the end of the word. But there is a very easy way in order to detect those issues. So what we're going to do, we're going to do a filter. So now we're going to say the first name is not equal to the first name after trimming the values. So if you use the function trim, what it's gonna do, it's gonna go and remove all the leading and trailing spaces. So the first name. So if this value is not equal to the first name after trimming it, then we have an issue. So it is very simple. Let's go and execute it. So now in the result, we will get a list of all first names where we have spaces, either at the start or at the end. So again, the expectation here is no results. And the same thing, we can go and check something else, like for example the last name. So let's go and do that over here and here. Let's go and execute it. We see in the results we have as well 17 customers where they have like space in their last name, which is not really good. And we can go and keep checking all the string values that we have inside the table. So for example the gender. So let's go and check that and execute. Now as you can see we don't have any results. That means the quality of the gender is better and we don't have any unwanted spaces. So now we have to go and write transformation in order to clean up those two columns. Now what I'm going to do, I'm just going to go and list all the columns in the query instead of the star. Alright, so now I have a list of all the columns that I need, and now what we have to do is to go to those two columns and start removing the unwanted spaces. So we will just use the trim. It's very simple. And give it a name, of course, the same name, and we will trim as well the last name. So let's go and query this. And with that, we have cleaned up those two columns from any unwanted spaces. Okay, so now moving on, we have those two informations. We have the marital status and as well the gender. If you check the values inside those two columns, as you can see, we have here low cardinality. So we have limited numbers of possible values that is used inside those two columns. So what we usually do is to go and check the data consistency inside those two columns. So it's very simple. What we're gonna do, we're gonna do the following. We're gonna say distinct, and we're gonna check the values. Let's go and do that. And now as you can see, we have only three possible values, either a null, F or M, which is okay. We can stay like this, of course, but we can make a rule in our project where we can say we will not be working with data abbreviations. We will go and use only friendly full names. So instead of having an F, we're gonna have like a full word female, and instead of M, we're gonna have like male, and we make it as a rule for the whole project. So each time we find the gender informations, we try to give the full name of it. So let's go and map those two values to a friendly one. So we're gonna go to the gender over here and say case when, and we're gonna say the gender is equal to F, then make it a female, and when it is equal to M, then map it to male. And now we have to make decision about the nulls. As you can see over here, we have nulls. So do we want to leave it as a null, or we want to use always the value unknown? So with that, we are replacing the missing values with a standard default value, or you can leave it as a null. But let's say in our project that we are replacing all the missing value with a default value. So let's go and do that. We're gonna say else. I'm gonna go with the NA, not available, or you can go with the unknown, of course. So that's for the gender information, like this, and we can go and remove the old one. And now there is one thing that I usually do in this case, where sometimes what happens, currently we are getting the capital F and the capital M, but maybe in the time something changed and you will get like lower M and lower F. So just to make sure in those cases we still are able to map those values to the correct value, what we're gonna do, we're gonna just use the function upper, just to make sure that if we get any lowercase values, we are able to catch it. So the same thing over here as well. And now one more thing that you can add as well, of course, if you are not trusting the data, because we saw some unwanted spaces in the first name and the last name, you might not trust that in the future you will get here as well unwanted spaces. You can go and make sure to trim everything just to make sure that you are catching all those cases. So that's it for now. Let's go and execute. Now, as you can see, we don't have an M and an F. We have a full word, male and female. And if we don't have a value, we don't have a null, we are getting here not available. Now we can go and do the same stuff for the marital status. You can see as well we have only three possibilities, the S, null and an M. We can go and do the same stuff. So I will just go and copy everything from here, and I will go and use the marital status and just remove this one from here. And now what are the possible values? We have the S, so it's gonna be single. We have an M for married, and we have as well a null, and with that we are getting the not available. So with that we are making as well data standardizations for this column. So let's go and execute it. Now as you can see, we don't have those short values. We have a full friendly value for the status and as well for the gender. And at the same time we are handling the nulls inside those two columns. So with that we are done with those two columns, and now we can go to the last one, that create date. For this type of informations, we make sure that this column is a real date and not as a string or varchar. And as we defined it in the data type, it is a date, which is completely correct, so nothing to do with this column. And now the next step is that we're gonna go and write the insert statement. So how we're gonna do it, we're gonna go to the start over here and say insert into silver.srm customer info. Now we have to go and specify all the columns that should be inserted. So we're gonna go and type it. So something like this, and then we have the query over here. Let's go and execute it. So let's do that. So with that, we have inserted clean data inside the silver table. So now what we're gonna do, we're gonna go and take all the queries that we have used in order to check the quality of the bronze, and let's go and take it to another query. And instead of having bronze, we're gonna say silver. So this is about the primary key. Let's go and execute it. Perfect. We don't have any results, so we don't have any duplicates. The same thing for the next one. So the silver, and it was for the first name. So let's go and check the first name and run it. As you can see, there is no results. It is perfect. We don't have any issues. You can of course go and check the last name and run it. Again, we don't have any result over here. And now we can go and check those low cardinality columns, like for example the gender. Let's go and execute it. So as you can see, we have the not available or the unknown, male and female. So perfect. And you can go and have a final look to the table, to the silver customer info. Let's go and check that. So now we can have a look to all those columns. As you can see, everything looks perfect. And you can see it is working, this metadata information that we have added to the table definition. Now it says when we have inserted all those records to the table, which is really amazing information to have a track and audit. Okay, so now by looking to this script, we have done different types of data transformations. The first one is with the first name and the last name. Here we have done trimming, removing unwanted spaces. This is one of the types of data cleansing. So we remove unnecessary spaces or unwanted characters to ensure data consistency. Now moving on to the next transformation, we have this case when. So what we have done here is data normalization, or we call it sometimes data standardization. So this transformation is type of data cleansing where we're gonna map coded values to meaningful user-friendly description. And we have done the same transformation as well to the gender. Another type of transformation that we have done as well in the same case when is that we have handled the missing values. So instead of nulls, we're gonna have not available. So handling missing data is as well type of data cleansing where we are filling the blanks by adding, for example, a default value. So instead of having an empty string or a null, we're gonna have a default value like the not available or unknown. Another type of data and transformations that we have done in this script is we have removed the duplicates. So removing duplicates is as well type of data cleansing where we ensure only one record for each primary key by identifying and retaining only the most relevant row to ensure there is no duplicates inside our data. And as we are removing the duplicates, of course, we are doing data filtering. So those are the different types of data transformations that we have done in this script. Alright, moving on to the second table in the bronze layer from the CRM, we have the product info. And of course, as usual, before we start writing any transformations, we have to search for data quality issues. And we start with the first one, we have to check the primary key. So we have to check whether we have duplicates or nulls inside this key. So what we have to do, we have to group up the data by the primary key or check whether we have nulls. So let's go and execute it. So as you can see, everything is safe. We don't have duplicates or nulls in the primary key. Now moving on to the next one, we have the product key. Here we have in this column a lot of informations. So now what we have to do is to go and split this string into two informations. So we are deriving new two columns. So now let's start with the first one is the category ID. The first 5 characters, they are actually the category ID, and we can go and use the substring function in order to extract part of a string. It needs 3 arguments. The first one gonna be the column that we want to extract from, and then we have to define the position where to extract. And since the first part is on the left side, we're gonna start from the first position, and then we have to specify the length. So how many characters we want to extract? We need 5 characters. So 1, 2, 3, 4, 5. So that's it for the category ID. Category ID, let's go and execute it. Now as you can see, we have a new column called the category ID, and it contains the first part of the string. And in our database from the other source system, we have as well the category ID. Now we can go and double check just in order to make sure that we can join data together. So we're gonna go and check the ID from the bronze table, ERP, and this is gonna be from the category. So in this table, we have the category IDs, and you can see over here, those are the IDs of the category, and in the code layer, we have to go and join those two tables. But here we still have an issue. We have here an underscore between the category and the subcategory, but in our table, we have actually a minus. So we have to replace that with an underscore in order to have matching informations between those two tables. Otherwise, we will not be able to join the tables. So we're going to use the function replace. And what we are replacing the minus with an underscore. Something like this. And if you go now and execute it, we will get an underscore exactly like the other table. And of course, we can go and check whether everything is matching by having very simple query where we say this new information not in, and then we have this nice subquery. So we are trying to find any category ID that is not available in the second table. So let's go and execute it. Now, as you can see, we have only one category that is not matching. We are not finding it in this table, which is maybe correct. So if you go over here, you will not find this category. I might just make it a little bit bigger. So we are not finding this one category from this table, which is fine. So our check is okay. Okay, so with that, we have the first part. Now we have to go and extract the second part, and we're going to do the same thing. So we're going to use the substring and the 3 argument, the product key. But this time we will not start cutting from the first position. We have to be in the middle. So 1, 2, 3, 4, 5, 6, 7. So we start from the position number 7. And now we have to define the length, how many characters to be extracted. But if you look over here, you can see that we have different length of the product keys. It is not fixed like the category ID. So we cannot go and here specify number. We have to make something dynamic. And there is a trick. In order to do that, we're going to go and use the length of the whole column. With that, we make sure that we are always getting enough characters to be extracted, and we will not be losing any informations. So we will make it dynamic like this. We will not have it as a fixed length. And with that, we have the product key. So let's go and execute it. As you can see, we are now extracting the second part from this string. Now, why we need the product key? We need it in order to join it with another table called sales details. So let's go and check the sales details. So let me just check the column name. It is SLS product key. So from bronze CRM sales. Let's go and check the data over here, and it looks wonderful. So actually we can go and join those informations together, but of course we can go and check that. So we're gonna say where, and we're gonna take our new column and we're gonna say not in the subquery, just to make sure that we are not missing anything. So let's go and execute. So it looks like we have a lot of products that don't have any orders. Well, I don't have nice feelings about it. Let's go and try something like this one here, and we say where SLS PRD key like this value over here. So I'll just cut the last 3 just to search inside this table. So we really don't have such a keys. Let me just cut the second one. So let's go and search for it. We don't have it as well. So anything that starts with the F key, we don't have any order with the product where it starts with the F key. So let's go and remove it, but still we are able to join the tables, right? So if I go and say in instead of not in, so with that you are able to match all those products. So that means everything is fine actually. It's just products that don't have any orders. So with that, I'm happy with this transformation. Now moving on to the next one, we have here the name of the product. We can go and check whether there is unwanted spaces. So let's go to our quality checks, make sure to use the same table, and we're going to use the product name and check whether we find any unmatching after trimming. So let's go and do it. Well, it looks really fine, so we don't have to trim anything. This column is safe. Now moving on to the next one, we have the costs. So here we have numbers and we have to check the quality of the numbers. So what we can do, we can check whether we have nulls or negative numbers. So negative costs or negative prices, which is not realistic, depend on the business of course. So let's say in our business we don't have any negative costs, so it's gonna be like this. Let's go and check whether it's something less than 0 or whether we have costs that is null. So let's go and check those informations. Well, as you can see, we don't have any negative values, but we have nulls. So we can go and handle that by replacing the null with a 0. Of course, if the business allow that. So in SQL Server, in order to replace the null with a 0, we have a very nice function called isNull. So we are saying if it is null, then replace this value with a 0. It is very simple, like this. And we give it a name, of course. So let's go and execute it. And as you can see, we don't have any more nulls. We have 0, which is better for the calculations if you are later doing any aggregate functions like the average. Now, moving on to the next one, we have the product line. This is again abbreviation of something, and the cardinality is low. So let's go and check all possible values inside this column. So we're just going to use the distinct, going to be BRD line. So let's go and execute it. And And as you can see, the possible values are null, MRST. And again, those are abbreviations, but in our data warehouse, we have decided to give full nice names. So we have to go and replace those codes, those abbreviations, with a friendly value. And of course, in order to get those informations, I usually go and ask the expert from the source system or an expert from the process. So let's start building our case win, and then let's use the upper and as well the trim just to make sure that we are having all the cases. So the BRD line is equal to, so let's start with the first value, the M. Then we will get the friendly value. It's going to be mountain. Then to the next one, so I will just copy and paste here. If it is an R, then it is road. And another one for, let me check, what do we have here? We have MR and then S. The S stands for other sales. And we have the T. So let's go and get the T. So the T stands for touring. We have at the end an else for unknown, not available. So we don't need any nulls. So that's it. And we're gonna name it as before. So product line. So let's remove the old one and let's execute it. And as you can see, we don't have here anymore those shortcuts and the abbreviations. We have now full friendly value, but I will go and have here like capital O. It looks nicer. So with that, we have nice friendly value. Now by looking to this case win, as you can see, it is always like we are mapping one value to another value, and we are repeating all time, upper time, and so on. We have here a quick form in the case win if it is just a simple mapping. So the syntax is very simple. We say case and then we have the column. So we are evaluating this value over here, and then we just say when without the equal. So if it is an M, then make it mountain. The same thing for the next one, and so with that we have the functions only once, and we don't have to go and keep repeating the same function over and over. And this one only if you are mapping values, but if you have complex conditions, you cannot do it like this. But for now, I'm gonna stay with the quick form of the case win. It looks nicer and shorter. So let's go and execute it. We will get the same results. Okay, so now back to our table. Let's go to the last two columns. We have the start and end date. So it's like defining an interval. We have start and end. So let's go and check the quality of the start and end dates. We're gonna go and say select star from our bronze table, and now we're gonna go and search it like this. We are searching for the end date that is smaller than the start. So BRD start dates. So let's go and query this. So you can see the start is always like after the end, which makes no sense at all. So we have here data issue with those two dates. So now for this kind of data transformations, what I usually do is I go and grab few examples and put it in Excel and try to think about how I'm gonna go and fix it. So here I took like two products, this one and this one over here. And for that we have like 3 rows for each one of them. And we have this situation over here. So the question now, how are we gonna go and fix it? I will go and make like a copy of one solution where we're gonna say, it's very simple. Let's go and switch the start date with the end date. So if I go and grab the end date and put it at the start, things gonna look way nicer, right? So we have the start is always younger than the end. But my friends, the data now makes no sense because we say it starts from 2007 and ends by 2011. The price was 12, but between 2008 and 2012, we have 14, which is not really good because if you take, for example, the year 2010, for 2010, it was 12 and at the same time 14. So it is really bad to have an overlapping between those two dates. It should start from 2007 and end with 11 and then start maybe from 12 and end with something else. There should be no overlapping between years. So it's not enough to say the start should be always smaller than the end, but as well the end of the first history should be younger than the start of the next record. This is as well a rule in order to have no overlapping. This one has no start but has already an end, which is not really okay because we have always to have a start. Each new record in historizations has to have a start. So for this record over here, this is as well wrong. And of course, it is okay to have the start without an end. So in this scenario, it's fine because this indicates this is the current informations about the costs. So again, this solution is not working at all. So now for the solution 2, what we can say, let's go and ignore completely the end date and we take only the start dates. So let's go and paste it over here. But now we go and rebuild the end date completely that we have defined. So the rule says the end of date of the current record comes from the start date from the next record. So here this end date comes from this value over here, from the next record. So that means we take the next start date and put it at the end date for the previous record. So with that, as you can see, it is working. The end date is higher than the start date. And as well, we are making sure this date is not overlapping with the next record. But as well, in order to make it way nicer, we can subtract it with 1. So we can take the previous day like this. So with that, we are making sure the end date is smaller than the next start. And now for the next record, this one over here, the end date gonna come from the next start date. So we will take this one for here and put it as an end date and subtract it with 1. So we will get the previous day. So now if you compare those two, you can see it's still higher than the start. And if you compare it with the next record, this one over here, it is still smaller than the next one, so there is no overlapping. And now for the last record, since we don't have here any informations, it will be a null, which is totally fine. So as you can see, I'm really happy with this scenario over here. Of course, you can go and validate this with an expert from the source system. Let's say I've done that and they approved it, and now I can go and clean up the data using this new logic. So this is how I usually brainstorm about fixing an issues. If I have like a complex stuff, I go and use Excel and then discuss it with the expert using this example. It's way better than showing a database, queries, and so on. It just makes things easier to explain and as well to discuss. So now how I usually do it, I usually go and make a focus on only the columns that I need and take only 1-2 scenarios while I'm building the logic, and once everything is ready, I go and integrate it in the query. So now I'm focusing only on these columns and only for these products. So now let's go and build our logic. Now in SQL, if you are at specific record and you want to access another information from another record, and for that we have 2 amazing window functions. We have the lead and lag. In this scenario, we want to access the next record. That's why we have to go with the function lead. So let's go and build it. Lead, and then what do we need? We need the lead of the start date. So we want the start date of the next record, and then we say over, and we have to partition the data. So the window gonna be focusing on only one product, which is the product key and not the product ID. So we are dividing the data by product key. And now of course we have to go and sort the data. So order by, and we are sorting the data by the start date and ascending, so from the lowest to the highest. And let's go and give it another name. So as, and let's say test, for example, just to test the data. So let's go and execute. And I think I missed something here. It is partition by. So let's go and execute again. And now let's go and check the results for the first partition over here. So the start is 2011 and the end is 2012. And this information came from the next record. So this data is moved to the previous record over here, and the same thing for this record. So the end date comes from the next record. So our logic is working, and the last record over here is null because we are at the end of the window and there is no next data. That's why we will get null, and this is perfect, of course. So it looks really awesome, but what is missing is we have to go and get the previous day, and we can do that very simply using -1. We are just subtracting 1 day, so we have no overlapping between those 2 dates, and the same thing for those 2 dates. So as you can see, we have just built a perfect end date, which is way better than the original data that we got from the source system. Now let's take this one over here and put it inside our query. So we don't need the end date, we need our new end date. We'll just remove that test and execute. Now it looks perfect. Alright, now we are not done yet with those 2 dates. Actually, we are saying all time dates because we don't have here any informations about the time, always 0. So it makes no sense to have these informations inside our data. So what we can do a very simple cast, and we make this column as a date instead of date time. So this is for the first one, and as well for the next one as dates. So let's try that out. And as you can see, it is nicer. We don't have the time informations. Of course, we can tell the source systems about all those issues, but since they don't provide the time, it makes no sense to have date and time. Okay, so it was a long run, but we have now a cleaned product informations, and this is way nicer than the original product information that we got from the source CRM. So if you grab the DDL of the server table, you can see that we don't have a category ID. So we have product ID and product key, and as well those 2 columns we just changed the data type. So it's date time here, but but we have changed that to a date. So that means we have to go and do few modifications to the DDL. So what we're gonna do, we're gonna go over here and say category ID, and I will be using the same data type. And for the start and the end, this time it's gonna be date and not date and time. So that's it for now. Let's go and execute it in order to repair the DDL. And this is what happened in the silver layer. Sometimes we have to adjust the metadata if the quality of the data types and so on is not good, or we are building new derived informations in order later to integrate the data. So it will be like very close to the bronze layer, but with few modifications. So make sure to update your DDL scripts. And now the next step is that we're gonna go and insert the data into the table. And now the next step, we're gonna go and insert the result of this query that is cleaning up the bronze table into the silver table. So as we've done it before, insert into silver the product info, and then we have to go and list all the columns. I've just prepared those columns, so with that we can go and now run our query in order to insert the data. So now as you can see, SQL did insert the data, and the very important step is now to check the quality of the silver table. So we go back to our data quality checks and we go switch to the silver. So let's check the primary key, there is no issues, and we can go and check, for example, here the trims, there is as well no issue. And now let's go and check the costs. It should not be negative or null, which is perfect. Let's go and check the data standardizations. As you can see, they are friendly and we don't have any nulls. And now, very interesting, the order of the dates. So let's go and check that. As you can see, we don't have any issues. And finally, what I do, I go and have a final look to the silver table, and as we can see, everything is inserted correctly in the correct columns. So all those columns comes from the source system, and the last one is automatically generated from the DDL, indicate when we loaded this table. Now let's sit back and have a look to our script. What are the different types of data transformations that we have done here? Is, for example, over here, the category ID and the product key, we have derived new columns. So it is when we create a new column based on calculations or transformations of an existing one. So sometimes we need columns only for analytics, and we cannot each time go to the source system and ask them to create it. So instead of that, we derive our own columns that we need for the analytics. Another transformation we have is the isNull over here. So we are handling here missing information. Instead of null, we're gonna have a 0. And one more transformation we have over here for the product line. We have done here data normalization. Instead of having a code value, we have a friendly value. And as well, we have handled the missing data. For example, over here, instead of having a null, we're gonna have not available. Alright, moving on to another data transformation, we have done data type casting. So we are converting the data type from one to another, and this considered as well to be a data transformation. And now moving on to the last one, we are doing as well data type casting, but what's more important, we are doing data enrichment. This type of transformation, it's all about adding value to your data. So we are adding new relevant data to our data sets. So those are the different types of data transformations that we have done for this table. Okay, so let's keep going. We have the sales details, and this is the last table in the CRM. So what do you have over here? We have the order number, and this is a string. Of course, we can go and check whether we have an issue with the unwanted spaces. So we can search whether we're gonna find something. So we can say trim and something like this, and let's go and execute it. So we can see that we don't have any unwanted spaces. That means we don't have to transform this column, so we can leave it as it is. Now the next two columns, they are like keys and IDs in order to connect it with the other tables. As we learned before, we are using the product key in order to connect it with the product informations, and we are connecting the customer ID with the customer ID from the customer info. So that means we have to go and check whether everything is working perfectly. So we can go and check the integrity of those columns, where we say the product key not in, and then we make a subquery, and this time we can work with the silver layer, right? So we can say the product key from silver.productinfo. So let's go and query this, and as you can see, we are not getting any issue. That means all the product keys from the sales details can be used and connected with the product info. The same thing, we can go and check the integrity of the customer ID, and we can use not the product. We can go to the customer info, and the name was CST ID. So let's go and query that, and the same thing, we don't have here any issues. So that means we can go and connect the sales with the customers using the customer ID, and we don't have to do any transformations for it. So things looks really nice for those three columns. Now we come to the challenging one. We have here the dates. Now those dates are not actual dates, they are integer. So those are numbers, and we don't want to have it like this. We would like to clean that up. We have to change the data type from integer to a date. Now, if you want to convert an integer to a date, we have to be careful with the values that we have inside each of those columns. So now let's check the quality, for example, of the order date. Let's say where order date is less than 0, for example, something negative. Well, we don't have any negative values, which is good. Let's go and check whether we have any zeros. Well, this is bad. So we have here a lot of zeros. Now what we can do, we can replace those informations with a null. We can use, of course, the null if function like this. We can say null if, and if it is 0, then make it null. So let's execute it. And as you can see now, all those informations are null. Now let's go and check again the data. So now this integer has the years information at the start, then the months, and then the day. So here we have to have like 1, 2, 3, 4, 5. So the length of each number should be 8. And if the length is less than 8 or higher than 8, then we have an issue. Let's go and check that. So we're gonna say or length sales order is not equal to 8. That means less or higher. Let's go and execute it. Now let's go and check the results over here. And those two informations, they don't look like a date. So we cannot go and make from these informations a real date. They are just bad data quality. And of course, you can go and check the boundaries of a date. Like for example, it should not be higher than, for example, let's go and get this value 2050 and then any for the month and the date. So let's go and execute it. And if we just remove those informations just to make sure, so we don't have any date that is outside of the boundaries that you have in your business. Or you go, for example, and say the boundary should be not less than, depend when your business started, maybe something like this. We are getting, of course, those values because they are less than a null, but if you have values around this date, you will get it as well in the query. So we can go and add the rests. So all those checks like validate the column that has date informations and it has the data type integer. So again, what are the issues over here? We have zeros and sometimes we have like strange numbers that cannot be converted to a date. So let's go and fix that in our query. So we can say case when the sales order, the order date is equal to 0 or of the order date is not equal to 8, then null, right? We don't want to deal with those values. They are just wrong and they are not real dates. Otherwise, we say else, it's gonna be the order date. Now what we're gonna do, we're gonna go and convert this to a date. We don't want this as an integer. So how we can do that? We can go and cast it first to a varchar, because we cannot cast from integer to date in SQL Server. First, you have to convert it to a varchar, and then from varchar, you go to a date. Well, this is how we do it in SQL Server. So we cast it first to a varchar, and then we cast it to a date, like this. That's it. So we have end, and we are using the same column name. So this is how we transform an integer to a date. So let's go and query this. And as you can see, the order date now is a real date. It is not a number. So we can go and get rid of the old column. Now we have to go and do the same stuff for the shipping date. So we can go over here and replace everything with the shipping date, and let's go and query. Well, as you can see, the shipping date is perfect. We don't have any issue with this column, but still I don't like that we found a lot of issues with the order date. So what we're gonna do, just in case this happens for the shipping date in the future, I will go and apply the same rules to the shipping date. So let's take the shipping date like this. And if you don't want to apply it now, you have always to build like quality checks that runs every day in order to detect those issues. And once you detect it, then you can go and do the transformations. But for now, I'm gonna apply it right away. So that is for the shipping date. Now we go to the due date and we will do the same tests. Let's go and execute it. And as well, it is perfect. So still, I'm gonna apply the same rules. So let's get the due date everywhere here in the query. Just make sure you don't miss anything here. So let's go and execute. Now, perfect. As you can see, we have the order date, shipping date, and due date. And all of them are date and don't have any wrong data inside those columns. Now, still, there is one more check that we can do, and it's that the order date should be always smaller than the shipping date or the due date. Because it makes no sense, right, if you are delivering an item without an order. So first, the order should happen, then we are shipping the items. So there is like an order of those dates, and we can go and check that. So we are checking now for invalid date orders, where we're gonna say the order date is higher than the shipping date, Or we are searching as well for an order where the order date is higher than the due date. So we can have it like this, due date. So let's go and check. Well, that's really good. We don't have such a mistake on the data and the quality looks good. So the order date is always smaller than the shipping date or the due date. So we don't have to do any transformations or cleanup. Okay, friends, now moving on to the last three columns. We have the sales, quantity, and the price. All those informations are connected to each other. So we have a business rule or calculation. It says the sales must be equal to quantity multiplied by the price. And all sales, quantity, and price informations must be positive numbers. So it's not allowed to be negative, zero, or a null. So those are the business rules, and we have to check the data consistency in our table. Does all those three informations following our rules? So we're gonna start first with our rule, right? So we're gonna say if the sales is not equal to quantity multiplied by the price. So we are searching where the result is not matching our expectation. And as well, we can go and check other stuff like the nulls. So for example, we can say or sales is null or quantity is null. And the last one for the price. And as well, we can go and check whether they are negative numbers or zero. So we can go over here and say less or equal to 0 and apply it for the other columns as well. So with that, we are checking the calculation, and as well we are checking whether we have null, 0, or negative numbers. Let's go and check our informations. I'm gonna have here a distinct. So let's go and query it. And of course we have here bad data, but we can go and sort the data by the sales, quantity, and the price. So let's do it. Now by looking to the data, we can see in the sales we have nulls, we have negative numbers, and zeros. So we have all bad combinations, and as well we have here bad calculations. So as you can see, the price here is 50, the quantity is 1, but the sales is 2, which is not correct. And here we have as well wrong calculations. Here we have to have a 10 and here 9, or maybe the price is wrong. And by looking to the quantity now, you can see we don't have any nulls, we don't have any zeros or negative numbers, so the quantity looks better than the sales. And if you look to the prices, we have nulls, we have negatives, and yeah, we don't have zeros. So that means the quality of the sales and the price is wrong, the calculation is not working, and we have these scenarios. Now, of course, how I do it here, I don't go and try now to transform everything on my own. I usually go and talk to an expert, maybe someone from the business or from the source system, and I show those scenarios and discuss. And usually there is like two answers. Either they're gonna tell me, you know what, I will fix it in my source, so I have to live with it. There is incoming bad data, and the bad data gonna be presented in the warehouse until the source system clean up those issues. And the other answer you might get, you know what, we don't have the budget and those data are really old and we are not going to do anything. So here you have to decide, either you leave it as it is, or you say, you know what, let's go and improve the quality of the data. But here you have to ask for the experts to support you solving these issues, because it really depends on the rules. Different rules makes different transformations. So now let's say that we have the following rules. If the sales informations are null or negative or 0, then use the calculation, the formula, by multiplying the quality with the price. And now if the prices are wrong, for example, we have here a null or 0, then go and calculate it from the sales and the quantity. And if you have a price that is a minus, like minus 21, a negative number, then you have to go and convert it to a 21. So from a negative to a positive without any calculations. So those are the rules, and now we're gonna go and build the transformations based on those rules. So let's do it step by step. I will go over here and we're gonna start building the new sales. So what is the rule says? Case when, of course, as usual, if the sales is null, or let's say the sales is negative number or equal to 0, or another scenario, we have a sales information but it is not following the calculation. So we have a wrong information in the sales, so we're gonna say the sales is not equal to the quantity multiplied by the price. But of course, we will not leave the price like this by using the function APS. The absolute, it's gonna go and convert everything from negative to a positive. Then what we have to do is to go and use the calculation. So it's gonna be the quantity multiplied by the price. So that means we are not using the value that's come from the source system, we are recalculating it. Now let's say the sales is correct and not one of those scenarios. So we're gonna say else, we will go with the sales as it is, that comes from the source, because it is correct. It's really nice. Let's go and say an end and give it the same name. I will go and rename the old one here as an old value. And the same for the price. The quantity will not touch it because it is correct. So like this. And now let's go and transform the prices. So again, as usual, we go with case when. So what are the scenarios? The price is null or the price is less or equal to 0. Then what we're gonna do? We're gonna do the calculation. So it's gonna be the sales divided by the quantity, the SLS quantity. But here we have to make sure that we are not dividing by 0. Currently we don't have any zeros in the quantity, but you don't know in the future you might get a 0 and the whole code gonna break. So what you have to do is to go and say, if you get any 0, replace it with a null. So null if it is 0, then make it null. So that's it. Now if the price is not null and the price is not negative or equal to 0, then everything is fine. And that's why we're gonna have now the else. It's gonna be the price as it is from the source system. So that's it. We're gonna say end as price. So I'm totally happy with that. Let's go and execute it and check, of course. So those are the old informations and those are the new transformed, cleaned up informations. So here previously we have a null, but now we have 2. So 2 multiplied with 1, we are getting 2. So the sales is here correct. Now moving on to the next one, we have in the sales 40, but the price is 2. So 2 multiplied with 1, we should get 2. So the new sales is correct. It is 2 and not 40. Now to the next one over here, the old sales is 0, but if you go and multiply the 4 with the quantity, you will get 4. So the sales here is not correct. That's why in the new sales, we have it correct as a 4. And let's go and get a minus. So in this case, we have a minus, which is not correct. So we are getting the price multiplied with 1. We should get here a 9, and this sales here is correct. Now let's go and get a scenario where the price is a null. Like this here. So we don't have here a price, but we calculated from the sales and the quantity. So we divided the 10 by 2 and we have 5. So the new price is better. And the same thing for the minuses. So we have here minus 21 and in the output we have 21, which is correct. So for now, I don't see any scenario where the data is wrong. So everything looks better than before. And with that, we have applied the business rules from the experts and we have cleaned up the data in the data warehouse. And this is way better than before because we are presenting now better data for analysis and reporting, but it is challenging and you have exactly to understand the business. So now what we're going to do, we're going to go and copy those informations and integrate it in our query. So instead of sales, we're going to get our new calculation, and instead of the price, we will get our correct calculation. And here I'm missing the end. Let's go and run the whole thing again. So with that, we have as well now cleaned sales, quantity, and price, and it is following our business rules. So with that, we are done cleaning up the sales details. The next step, we're going to go and insert it to the sales details, but we have to go and check again the DDL. So now all what you have to do is to compare those results with the DDL. So the first one is the order number, it's fine, the product key, the customer ID, but here we have an issue. All those informations now are date and not an integer, so we have to go and change the data type. And with that, we have better data type than before. Then the sales quantity price, it is correct. Let's go and drop the table and create it from scratch again. And don't forget to update your DDL script. So that's it for this. And we're going to go now and insert the results into our silver table, sales details. And we have to go and list now all the columns. I have already prepared the list of all the columns. So make sure that you have the correct order of the columns. So let's go now and insert the data. And with that, we can see that the SQL did insert data to our sales details. But now very important is to check the health of the silver table. So what you're going to do instead here of bronze, we're going to go and switch it to silver. So let's check over here. So here always the order is smaller than the shipping and the due date, which is really nice. But now I'm very interested on the calculations. So here we're going to switch it from bronze to silver. And I'm going to go and get rid of all those calculations because we don't need it. This, and now let's see whether we have any issue. Well, perfect. Our data is following the business rules. We don't have any nulls, negative values, zeros. Now, as usual, the last step, the final check. We will just have a final look to the table. So we have the order number, the product key, the customer ID, the 3 dates, we have the sales, quantity, and the price. And of course, we have our metadata column. Everything is perfect. So now by looking to our code, what are the different types of data transformations that we are doing? So on those 3 columns, we are doing the following. So at the start, we are handling invalid data. And this is as well type of transformation. And as well at the same time, we are doing data type casting. So we are changing it to more correct data type. And if you are looking to the sales over here, then what we are doing over here is we are handling the missing data and as well the invalid data by deriving the column from already existing one. And it is as well very similar for the price. We are handling as well the invalid data by deriving it from specific calculation over here. So those are the different types of data transformations that you have done in this script. Now let's keep moving to the next star system. We have the customer AZ12. So here we have like only 3 columns, and let's start with the ID first. So here again we have the customer's informations, and if we go and check again our model, you can see that we can connect this table with the CRM table customer info using the customer key. So that means we have to go and make sure that we can go and connect those 2 tables. So let's go and check the other table. We can go and check, of course, the server layer. So let's query it, and we can query both of the tables. Now we can see there is here like extra characters that are not included in the customer key from the CRM. So let's go and search, for example, for this customer over here, where CID like, so we are searching for a customer has similar ID. Now as you can see, we are finding this customer, but the issue is that we have those 3 characters in AS. There is no specifications or explanation why we have the NAS. So actually what we have to do is to go and remove those informations. We don't need it. So let's again check the data. So it looks like the old data have an NAS at the start, and then afterward we have new data without those 3 characters. So we have to clean up those IDs in order to be able to connect it with other tables. So we're gonna do it like this. We're gonna start with the case when, since we have like 2 scenarios in our data. So if the CID is like the 3 characters in AS, so if the ID starts with those 3 characters, then we're gonna go and apply transformation function. Otherwise, it's gonna stay like it is. So that's it. So now we have to go and build the transformation. So we're gonna use substring, and then we have to define the string. It's gonna be the CID, and then we have to define the position where it starts cutting or extracting. So we can say 1, 2, 3, and then 4. So we have to define the position number 4, and then we have to define the string, how many characters should be extracted. I will make it dynamic, so I will go with the length. I will not go and count how much. So we're gonna say the CID. So it looks good. If it's like in AS, then go and extract from the CID at the position number 4 the rest of the characters. So let's go and execute it. And I'm missing here a comma again, where we don't have any NAS at the start. And if you scroll down, you can see those as well are not affected. So with that, we have now a nice ID to be joined with the other table. Of course, we can go and test it like this, where and then we take the whole thing, the whole transformation, and say not in. We remove, of course, the alias name. We don't need it. And then we make very simple substring select distinct CST key, the customer key, from the silver table. It can be silver CRM cost info. So that's it. Let's go and check. So as you can see, it is working fine. So we are not able to find any unmatching data between the customer info from ERB and the CRM, but of course, after the transformation. If you don't use the transformation, so if I just remove it like this, we will find a lot of unmatching data. So this means our transformation is working perfectly, and we can go and remove the original value. So that's it for the first column. Okay, now moving on to the next field, we have the birthday of the customers. So the first thing to do is to check the data type. It is a date. So it's fine. It is not an integer or a string, so we don't have to convert anything, but still there is something to check with the birth date. So we can check whether we have something out of range. So for example, we can go and check whether we have really old dates at the birth dates. So let's take 1900 and let's say 24, and we can take the first date of the month. So let's go and check that. Well, it looks like that we have customers that are older than 100 years. Well, I don't know, maybe this is correct, but it sounds, of course, strange, depends on the business, of course.
Hey, this is Creed. and he is in charge of something,
That
right?
is correct.
Say hi to the kids.
Hi, kids.
Yay!
And then we can go and check the other boundary where it is almost impossible to have a customer that the birthday is in the future. So we can say birth date is higher than the current date, like this. So let's go and query this information. Well, it will not work because we have to have like an OR between them. And now if we check the list over here, we have dates that are invalid for the birth dates. So all those dates, they are all birthday in the future, and this is totally unacceptable. So this is an indicator for bad data quality. Of course, you can go and report it to the source system in order to correct it. So here it's up to you what to do with those dates. Either leave it as it is as a bad data, or we can go and clean that up by replacing all those dates with a null, or maybe replacing only the one that is extreme, where it is 100% is incorrect. So let's go and write the transformation for that. As usual, we're gonna start with case when birth date is larger than the current date and time, then null. Otherwise, we can have an else where we have the birth date as it is, and then we have an end as birth date. So let's go and execute it. And with that, we should not get any customer where the birthday in the future. So that's it for the birth date. Now let's move to the next one. We have the gender. Now again, the gender informations is low cardinalities. So we have to go and check all the possible values inside this column. So in order to check all the possible values, we're going to use select distinct gen from our table. So let's go and execute it. And now the data doesn't look really good. So we have here a null, we have an F, we have here an empty string, we have male, female, and again we have the M. So this is not really good. What we're gonna do, we're gonna go and clean up all those informations in order to have only 3 values: male, female, and not available. So we're gonna do it like this. We're gonna say case when, and now we're gonna go and trim the values just to make sure there is like no empty spaces. And as well, I'm gonna go and use the upper function just to make sure that in the future, if we get any lower cases and so on, we are covering all the different scenarios. So case, this is in F4, let's say female, then make it as female. And we can go and do the same thing for the male, like this. So if it is an M or a male, make sure it is capital letters because here we are using the upper, then it is a male. Otherwise, all other scenarios, it should be not available. So whether it is an empty string or nulls and so on. So we have to have an end, of course, as gen. So now let's go and test it and check whether we have covered everything. So you can see the M is now male, the empty is not available, the F is female, the empty string or maybe spaces here is not available. Female gonna stay as it is, and the same for the male. So with that, we are covering all the scenarios and we are following our standards in the project. So I'm gonna go and cut this and put it in our original query over here. So let's go and execute the whole thing. And with that, we have cleaned up all those 3 columns. Now the question is, did we change anything in the DDL? Well, we didn't change anything. We didn't introduce any new column or change any data type. So that means the next step is we're gonna go and insert it in the server layer. So as usual, we're gonna say here, insert into silver ERP the customer, and then we're gonna go and list all the column names. So CID, birth date, and the gender. Alright, so let's go and execute it. And with that, we can see it inserted all the data. And of course, the very important step as the next is to check the data quality. So let's go back to our query over here and change it from bronze to silver. So let's go and check the silver layer. Well, of course, we are getting those very old customers, but we didn't change that. We only change the birthday that is in the future, and we don't see it here in the results. So that means everything is clean. So for the next one, let's go and check the different genders. And as you can see, we have only those 3 values. And of course, we can go and take a final look to our table. So you can see the CID here, the birth date, gender, and then we see our metadata column. And everything looks amazing. So that's it. What are the different types of data transformations that we have done? First, with the ID, what we have done, we have handled invalid values. So we have removed this part where it is not needed. And the same thing goes for the birth dates. We have handled as well invalid values. And then for the last one, for the gender, we have done data normalizations by mapping the code to more friendly value. And as well, we have handled the missing values. So those are the types that we have done in this code. Okay, moving on to the second table, we have the location informations. So we have ERP location A101. So now here the task is easy because we have only 2 columns. And if you go and check the integration model, we can find our table over here. So we can go and connect it together with the customer info from the other system using the CIID with the customer key. So those 2 informations must be matching in order to join the tables. So that means we have to go and check the data. So let's go and select the data, CST key from, let's go and get the silver data, customer info. So let's go. Now if you go and check the result, you can see over here that we have an issue with the CIID. There is like a minus between the characters and the numbers, but the customer ID, the customer number, we don't have anything that splits the characters with the numbers. So if you go and join those 2 informations, it will not be working. So what we have to do, we have to go and get rid of this minus because it is totally unnecessary. So let's go and fix that. It's going to be very simple. So what we're going to do, we're going to say CIID. So we're going to go and search for the minus and replace it with nothing. It's very simple like this. So let's go and query it again. And with that, things looks very similar to each other's. And as well, we can go and query it. So we're going to say where our transformation is not in, then we can go and use this as a subquery like this. So let's go and execute it. And as you can see, we are not finding any unmatching data now. So that means our transformation is working. And with that, we can go and connect those 2 tables together. So if I take the transformation away, you can see that we will find a lot of unmatching data. So the transformation is okay. We're going to stay with it. And now let's speak about the countries. Now we have here multiple values and so on. What I'm going to do, this is low cardinality and we have to go and check all possible values inside this column. So that means we are checking whether the data is consistent. So we can do it like this, distinct the country from our table. I'm just going to go and copy it like this. And as well, I'm going to go and sort the data by the country. So let's go and check the informations. Now you can see we have a null, we have an empty string, which is really bad. And then we have a full name of country. And then we have as well an abbreviation of the countries. Well, this is a mix. This is not really good because sometimes we have DE and sometimes we have Germany. And then we have the United Kingdom. And then for the United States, we have like 3 versions of the same information, which is as well not really good. So the quality of the country is not really good. So let's go and work on the transformation. As usual, we're going to start with the case when. If trim country is equal to DE, then we're going to transform it to Germany. And the next one, it's going to be about the USA. So if trim country is in, so now let's go and get those 2 values, the US and the USA. So US and USA, then it's going to be the United States. So with that, we have covered as well those 3 cases. Now we have to talk about the null and the empty string. So we're going to say when trim country is equal to empty string or country is null, then it's going to be not available. Otherwise, I would like to get the country as it is. So trim country, just to make sure that we don't have any leading or trailing spaces. So that's it. Let's go and say this is the country. So it is working and the country information is transformed. And now what I'm going to do, I'm going to take the whole new transformation and compare it to the old one. Let me just call this as old country and let's go and query it. So now we can check those values stayed as before. So nothing did change. The DE is now Germany. The empty string is not available. The null, the same thing. And the United Kingdom stayed as it's like before. And now we have 1 value for all those information. So it's only the United States. So it looks perfect. And with that, we have cleaned as well the second column. So with that, we have now clean results. And now the question, did we change anything in the DDL? Well, we haven't changed anything. Both of them are varchar. So we can go now immediately and insert it into our table. So insert into silver customer location. And here we have to specify the columns. It's very simple, the ID and the country. So let's go and execute it. And as you can see, we got now inserted all those values. Of course, as a next, we go and double check those informations. I will just go and remove all those stuff as well here. And instead of bronze, let's go go with the silver. So as you can see, all the values of the country looks good. And let's have a final look to the table. So like this. So we have the IDs without the separator. We have the countries and as well our metadata information. So with that, we have cleaned up the data for the location. Okay, so now what are the different types of data transformation that we have done here? Is first, we have handled invalid values. So we have removed the minus with an empty string. And for the country, we have done data normalization. So we have replaced codes with friendly values. And as well at the same time, we have handled missing values by replacing the empty string and null with not available. And one more thing, of course, we have removed the unwanted spaces. So those are the different types of transformation that we have done for this table. Okay guys, now keep the energy up, keep the spirit up. We have to go and clean up the last table in the bronze layer. And of course, we cannot go and skip anything. We have to check the quality and to detect all the errors. So now we have a table about the categories for the products. And here we have like 4 columns. Let's go and start with the first one, the ID. As you can see in our integration model, we can connect this table together with the product info from the CRM using the product key. And as you remember in the silver layer, we have created an extra column for that in the product info. So if you go and select those data, you can see we have a column called category ID, and this one is exactly matching the ID that we have in this table. And we have done the testing, so this ID is ready to be used together with the other table. So there is nothing to do over here. And now for the next columns, they are string, and of course we can go and check whether there are any unwanted spaces. So we are checking for the unwanted spaces. So let's go and check. Select start from, and we're gonna go and get the same table like this here. And first we are checking the category. So the category is not equal to the category after trimming the unwanted spaces. So let's go and execute it. And as you can see, we don't have any results. So there are no unwanted spaces. Let's go and check the other column. For example, the subcategory, the next one. So let's get the subcategory and run the query. As well, we don't have anything. So that means we don't have unwanted spaces for the subcategory. Let's go now and check the last column. So I will just copy and paste now. Let's get the maintenance and let's go and execute. And as well, no results. Perfect. We don't have any unwanted spaces inside this table. So now the next step is that we're going to go and check the data standardizations because all those columns has low cardinality. So what we're going to do, we're going to say select distinct. Let's get the category from our table. I'll just copy and paste it and check all values. So as you can see, we have the accessories, bikes, clothing, and components. Everything looks perfect. We don't have to change anything in this column. Let's go and check the subcategory. And if you scroll down, all values are friendly and nice. As well, nothing to change here. And let's go and check the last column, the maintenance. Perfect. We have only 2 values, yes and no. We don't have any nulls. So my friends, that means this table has really nice data quality and we don't have to clean up anything, but still we have to follow our process. We have to go and load it from the bronze to the silver even if we didn't transform anything. So our job is really easy here. We're gonna go and say insert into silver.erp px and so on, and we're gonna go and define the columns. So it's gonna be the ID, the category, subcategory, maintenance. So that's it. Let's go and insert the data. Now as usual, what we're gonna do, we're gonna go and check the data. So silver ERP px. Let's have a look. Alright, so we can see the IDs are here, the categories, the subcategories, the maintenance, and we have our meta column. So everything is inserted correctly. Alright, so now I have all those queries and the insert statements for all 6 tables. And now what is important before inserting any data, we have to make sure that we are truncating and emptying the table. Because if you run this query twice, what's gonna happen, you will be inserting duplicates. So first, truncate the data and then do a full load. Insert all data. So we're gonna have one step before. It's like the bronze layer. We're gonna say truncate table, and then we will be truncating the silver customer info. And only only after that we have to go and insert the data. And of course we can go and give this nice information at the start. So first we are truncating the table and then inserting. So if I go and run the whole thing, so let's go and do it, it will be working. So if I can run it again, we will not have any duplicates. So we have to go and add this step before each insert. So let's go and do that. Alright, so I'm done with all tables. So now let's go and run everything. So let's go and execute it, and we can see in the messaging everything working perfectly. So with that we made all tables empty and then we inserted the data. So perfect. With that we have a nice script that loads the silver layer, but of course like the bronze layer we're gonna put everything in one stored procedure. So let's go and do that. We'll go to the beginning over here and say create or alter procedure, and we're gonna put it in the schema silver, and using the naming convention load silver, and we're gonna go over here and say begin and take the whole code, and it is long one, and give it one push with the tab, and then at the end we're gonna say end. Perfect. So we have our stored procedure, but we forgot here the as. With that we will not have any error. Let's go and execute it. So the stored procedure is created. If you go to the programmability, and you will find two procedures, load bronze and load silver. So now let's go and try it out. All what you have to do is now only to execute the silver load silver. So let's execute the stored procedure, and with that we will get the same results. This stored procedure now is responsible of loading the whole silver layer. Now of course the messaging here is not really good, because we have learned in the bronze layer we can go and add many stuff like handling the error, doing nice messaging, catching the duration time. So now your task is to pause the video, take this stored procedure and go and transform it to be very similar to the bronze layer with the same messaging and all the add-ons that we have added. So pause the video now, I will do it as well offline, and I will see you soon. Okay, so I hope you are done. And I can show you the results. It's like the bronze layer. We have defined at the start few variables in order to catch the duration. So we have the start time, the end time, batch start time, and batch end time. And then we are printing a lot of stuff in order to have like nice messaging in the output. So at the start we are saying loading the silver layer, and then we start splitting by the source system. So loading the CRM tables, and I'm going to show you only one table for now. So we are setting the timer. So we are saying start time, get the date and time information to it. Then we are doing the usual, we are truncating the table, and then we are inserting the new informations after cleaning it up. And we have this nice message where we say load duration, where we are finding the differences between the start time and the end time using the function dateDiff, and we want to show the result in the seconds. So we are just printing how long it took to load this table, and we can go and repeat this process for all the tables. And of course we are putting everything in try and catch. So the SQL gonna go and try to execute the try part, and if there are any issues, the SQL gonna go and execute the catch. And here we are just printing few information like the error message, the error number, and the error state. And we are following exactly the same standards as the bronze layer. So let's go and execute the whole thing. And with that we have updated the definition of the stored procedure. Let's go now and execute it. So execute silver.load silver. So let's go and do that. It went very fast, like fewer than 1 second. Again, because we are working on local machine, loading the silver layer, loading the CRM tables, and we can see this nice messaging. So it starts with truncating the table, inserting the data, and we are getting the load duration for this table. And you will see that everything is below 1 second, and that's because but in real projects you will get, of course, more than 1 second. So at the end we have load duration of the whole silver layer. And now I have one more thing for you. Let's say that you are changing the design of this stored procedure for the silver layer. You are adding different types of messaging, or maybe you are creating logs and so on. So now all those new ideas and redesigns that you are doing for the silver layer, you have always to think about bringing the same changes as well in the other stored procedure for the bronze layer. So always try to keep your codes following the same standards. Don't have like one idea in one stored procedure and an old idea idea in another one. Always try to maintain those scripts and to keep them all up to date following the same standards. Otherwise, it's gonna be really hard for other developers to understand the codes. I know that needs a lot of work and commitment, but this is your job to make everything following the best practices and following the same naming convention and standards that you put for your projects. So guys, now we have very nice two ETL scripts, one that loads the bronze layer and another one for the silver layer. So now our data warehouse is very simple. All what you have to do is to run first the bronze layer, and with that we are taking all the data from the CSV files from the source and we put it inside our data warehouse in the bronze layer, and with that we are refreshing the whole bronze layer. Once it's done, the next step is to run the stored procedure of the silver layer. So once you execute it, you are taking now all the data from the bronze layer, transforming it, cleaning it up, and then loading it to the silver layer. And as you can see, the concept is very simple. We are just moving the data from one layer another layer with different tasks. Alright guys, so as you can see in the silver layer, we have done a lot of data transformations and we have covered all the types that we have in the data cleansing. So we remove duplicates, data filtering, handling missing data, invalid data, unwanted spaces, casting the data types, and so on. And as well, we have derived new columns, we have done data enrichment, and we have normalized a lot of data. So now, of course, what we have not done yet, business rules and logic, data aggregations, and data integration. This is for the next layer. Alright my friends, so finally we are done cleaning up the data and checking the quality of our data. So we can go and close those two steps. And now to the next step, we have to go and extend the data flow diagram. So let's go. Okay, so now let's go and extend our data flow for the silver layer. So what I'm gonna do, I'm just gonna go and copy the whole thing and put it side by side to the bronze layer, and let's call it silver layer, and the table name is going to stay as before because we have like one-to-one like the bronze layer. But what we're going to do, we're going to go and change the coloring. So I'm going to go and mark everything and make it gray like silver. And of course, what is very important is to make the lineage. So I'm going to go now from the bronze and take an arrow and put it to the silver table. And now with that, we have like a lineage between three layers. And you are checking this table, the customer info. You can understand, this comes from the bronze layer, from the customer info, and as well this comes from the source system CRM. So now you can see the lineage between different layers, and without looking to any scripts and so on, in one picture you can understand the whole project. So I don't have to explain a lot of stuff. By just looking to this picture, you can understand how the data is flowing between sources, bronze layer, silver layer, and to the gold layer, of course, later. So as you can see, it looks really nice and clean. Alright, so with that we have updated the data flow. Next we're gonna go and commit our work in the Git repo. So let's go. Okay, so now let's go and commit our scripts. We're gonna go to the folder scripts, and here we have a silver layer. If you don't have it, of course, you can go and create it. So first, we're gonna go and put the DDL scripts for the silver layer. So let's go, and I will paste the code over here. And as usual, we have this comment at the header explaining the purpose of this script. So let's go and commit our work. And we're gonna do the same thing for the stored procedure that loads the silver layer. So I'm gonna go over here. I have already a file for that. So let's go and paste that. So we have here our stored procedures. And as usual, at the start, we have as well. So this script is doing the ETL process where we load the data from bronze into silver. So the action is to truncate the table first and then insert transformed cleansed data from bronze to silver. There are no parameters at all. And this is how you can use the stored procedure. Okay, so we're gonna go and commit our work. And now one more thing that we want to commit in our projects, all those queries that we have built to check the quality of the silver layer. So this time we will not put it in the scripts, we're gonna go to the tests, and here we're gonna go and make a new file called quality checks silver, and inside it we're gonna go and paste all the queries that we have built. I just here reorganize them by the tables. So here we can see all the checks that we have done during the course, and at the header we have here nice comments. So here we are just saying that this script it's gonna check the quality of the server layer, and we are checking for nulls, duplicates, unwanted spaces, invalid date range, and so on. So with that, each time you come up with a new quality check, I'm gonna recommend you to share it with the project and with the other team in order to make it part of multiple checks that you do after running the ETLs. So that's it. I'm gonna go and put those checks in our repo, and in case I come up with new check, I'm gonna go and update it. Perfect, so now we have our code in our repository. Alright, so with that our code is safe and we are done with the whole epic. So we have built the silver layer. Now let's go and minimize it. And now we come to my favorite layer, the gold layer. So we're gonna go and build it. The first step, as usual, we have to analyze, and this time we're gonna explore the business objects. So let's go. Alright, so now we come to the big question, how are we going to build the gold layer? As usual, we start with analyzing. So now what we're going to do here is to explore and understand what are the main business objects that are hidden inside our source system. So as you can see, we have 2 sources, 6 files, and here we have to identify what are the business objects. Once we have this understanding, then we can start coding. And here the main transformation that we are doing is data integration. And here usually I split it into 3 steps. The first one, we're going to go and build those business objects that we have identified, and after we have a business object, we have to look at it and decide what is the type of this table. Is it a dimension? Is it a fact? Or is it like maybe a flat table? So what type of table that we have built? And the last step is, of course, we have now to rename all the columns into something friendly and easy to understand so that our consumers don't struggle with technical names. So once we have all those steps, what we're gonna do, it's time to validate what you have created. So what we have to do, the new data model that we have created, it should be connectable, and we have to check that the data integration is done correctly. And once everything is fine, we cannot skip the last step. We have to document and as well commit our work in the Git. And here we will be introducing a new type of documentations. So we're gonna have a diagram about the data model. We're gonna build a data dictionary where we're gonna describe the data model. And of course, we're gonna extend the data flow diagram. So this is our process. Those are the main steps that we will do in order to build the gold layer. Okay, so what is exactly data modeling? Usually the source system gonna deliver for you raw data, unorganized, messy, not very useful in its current state. But now the data modeling is the process of taking this raw data and then organize it and structure it in meaningful way. So what we are doing, we are putting the data in a new, friendly and easy to understand objects like customers, orders, products. Each one of them is focused on specific information, and what is very important is we're gonna describe the relationship between those objects. So by connecting them using lines. So what you have built on the right side, we call it logical data model. If you compare to the left side, you can see the data model makes it really easy to understand our data and the relationship, the processes behind them. Now in data modeling, we have 3 different stages, or let's say 3 different ways on how to draw a data model. The first stage is the conceptual data model. Here the focus is only on the entity. So we have customers, orders, products, and we don't go in details at all. So we don't specify any columns or attributes inside those boxes. We just want to focus what are the entities that we have and as well the relationship between them. So the conceptual data model don't focus at all on the details. It just gives the big picture. So the second data model that we can build is the logical data model. And here we start specifying what are the different columns that we can find in each entity. Like we have the customer ID, the first name, last name, and so on. And we still draw the relationship between those entities, and as well we make it clear which columns are the primary key and so on. So as you can see, we have here more details, but one thing, we don't describe a lot of details for each column, and we are not worried how exactly we're gonna store those tables in the database. The third and last stage, we have the physical data model. This is where everything gets ready before creating it in the database. So here you have to add all the technical details, like adding for each column the data types and the length of each data type and many other database techniques and details. So again, if you look to the conceptual data model, it gives us the big picture, and in the logical data model we dive into details of what data we need, and the physical layer model prepares everything for the implementation in the database. And to be honest, in my projects I only draw the conceptual and the logical data model, because drawing and building the physical data model needs a lot of efforts and time, and there are many tools like in Databricks, they automatically generate those models. So in this project, what we're gonna do, we're gonna draw the logical data model for the gold layer. Alright, so now for analytics and especially for data warehousing and business intelligence, we need a special data model that is optimized for reporting and analytics, and it should be flexible, scalable, and as well easy to understand. And for that, we have two special data models. The first type of data model, we have the star schema. It has a central fact table in the middle and surrounded by dimensions. The fact table contains transactions, events, and the dimensions contains descriptive informations. And the relationship between the fact table in the middle and the dimensions around it forms like a star shape, and that's why we call it star schema. And we have another data model called Snowflake schema. It looks very similar to the star schema, so we have again the fact in the middle and surrounded by dimensions, but the big difference is that we break the dimensions into smaller sub-dimensions. And the shape of this data model, as you are extending the dimensions, it's gonna look like a snowflake. So now if you compare them side by side, you can see that the star schema looks easier, right? So it is usually easy to understand, easy to query. It is really perfect for analysis. But it has one issue with that: the dimension might contain duplicates and your dimensions get bigger with the time. Now if you compare it to the snowflake, you can see the schema is more complex. So you need a lot of knowledge and efforts in order to query something from the snowflake. But the main advantage here comes with the normalization. As you are breaking those redundancies in small tables, you can optimize the storage. But to be honest, who cares about the storage? So for this project, I have chosen to use the star schema because it is very commonly used, perfect for reporting, like for example if you are using Power BI, and we don't have to worry about the storage. So that's why we're gonna adopt this model to build our gold layer. Okay, so now one more thing about those data models, that they contain two types of tables, fact and dimensions. So when I say this is a fact table or a dimension table, well, the dimension contains descriptive informations or like categories that gives some context to your data. For example, a product info, you have product name, category, subcategories, and so on. This is like a table that is describing the product, and this we call it a dimension. But on the other hand, we have facts. They are events like transactions. They contain three important informations. First, you have multiple IDs from multiple dimensions. Then we have like date informations, like when the transaction or the event did happen. And the third type of information, you're gonna have like measures and numbers. So if you see those three types of data in one table, then this is a fact. So if you have a table that answers how much or how many, then this is a fact. But if you have a table that answers who, what, where, then this is a dimension table. So this is what dimension and fact tables. My friends, so far in the bronze layer and in the silver layer, we didn't discuss anything about the business. So the bronze and silver were very technical. We are focusing on data ingestion, we are focusing on cleaning up the data quality of the data, but still the tables are very oriented to the source system. Now comes the fun part in the gold layer, where we're gonna go and break the whole data model of the sources. So we're gonna create something completely new to our business that is easy to consume for business reporting and analysis. And here it is very important to have a clear understanding of the business and the processes. And if you don't know it already at this phase, you have really to invest time by meeting maybe process experts, the domain experts, in order to have clear understanding what we are talking about in the data. So now what we're gonna do, we're gonna try to detect what are the business objects that are hidden in the source systems. So now let's go and explore that. Alright, now in order to build a new data model, I have to understand first the original data model. What are the main business objects that we have, how things are related to each others, and this is very important process in building a new model. So now what I usually do, I start giving labels to all those tables. So if you go to the shapes over here, let's go and search for label, and if you go to more icons, I'm gonna go and take this label over here, so drag and drop it, and then I'm gonna go and increase maybe the size of the font. So let's go with 20. And bold, just make it a little bit bigger. So now by looking to this data model, we can see that we have product informations in the CRM and as well in the ERP, and then we have like customer informations and transactional table. So now let's focus on the products. So the product information is over here. We have here the current and the history product informations, and here we have the categories that belong to the products. So in our data model, we have something called products. So let's go and create this label. It's gonna be the products. And let's go and give it a color to the style. Let's pick, for example, the red one. Now let's go and move this label and put it beneath this table over here. And with that, I have like a label saying this table belongs to the objects called products. Now I'm going to do the same thing for the other table over here. So I'm going to go and tag this table to the product as well. So with that, I can see easily which tables from the sources has informations about the product's business object. All right, now moving on, we have here a table called customer information. So we have a lot of information about the customer. We have as well in the ERP customer information where we have the birthday and the country. So those three tables has to do with the object's customer. So that means we're going to go and label it like that. So let's call it customer, and I'm going to go and pick different color for that. Let's go with the green. So I will tag this table like this, and the same thing for the other tables. So copy, tag the second table and the third table. Now it is very easily for me to see which table to belong to which business objects. And now we have the final table over here and only one table about the sales and orders. In the ARB we don't have any information about that. So this one gonna be easy. Let's call it sales. And let's move it over here, and as well maybe change the color of that to, for example, this color over here. Now this step is very important by building any data model in the gold layer. It gives you a big picture about the things that you are going to model. So now the next step is that we're going to go and build those objects step by step. So let's start with the first object with our customers. So here we have three tables and we're going to start with the CRM. So let's start with this table over here. Alright, so with that we know what are our business objects and this task is done. And now in the next step, we're going to go back to SQL and start doing data integrations and building completely new data model. So let's go and do that. Now let's have a quick look to the gold layer specifications. So this is the final stage. We're going to provide data to be consumed by reporting and analytics. And this time we will not be building tables. We will be using views. So that means we will not be having like stored procedure or any load process to the gold layer. All what we are doing is only data transformation. And the focus of the data transformation is going to be data integration, aggregation, business logic, and so on. And this time we're going to introduce a new data model. We will be doing star schema. So those are the specifications for the gold layer, and this is our scope. So this time we make sure that we are selecting data from the silver layer, not from the bronze, because the bronze has bad data quality and the silver is everything is prepared and cleaned up. In order to build the gold layer, we're gonna be targeting the silver layer. So let's start with select star from, and we're gonna go to the silver CRM customer info. So let's go and hit execute, and now we're gonna go and select the columns that we need to be presented in the gold layer. So let's start selecting the columns that we want. We have the ID, the key, the first name. I will not go and get the metadata information. This only belongs to the silver. Perfect. The next step is that I'm gonna go and give this table an alias. So let's go and call it CI, and I'm gonna make sure that we are selecting from this alias because later we're gonna go and join this table with other tables. So something like this. So we're gonna go with those columns. Now let's move to the second table. Let's go and get the birthday information. So now we're gonna jump to the other system and we have to join the data by the CI ID together with the customer key. So now we have to go and join the data with another table, and here I try to avoid using the inner join because if the other table doesn't have all the information about the customers, I might lose customers. So always start with the master table, and if you join it with any other table in order to get informations, try always to avoid the inner join because the other source might not have all the customers, and if you do inner join you might lose customers. So I tend to start from the master table and then everything else is about the left join. So I'm going to say left join silver ERP customer AZ12. So let's give it the alias CA, and now we have to join the tables. So it's going to be by CE from the first table. It's going to be the customer key equal to CA, and we have the CI ID. Now of course we're going to get matching data because we checked the silver layer, but if we haven't prepared the data in the silver layer, we have to do here a preparation step in order to join the tables, but we don't have to do that because that was a pre-step in the silver layer. So now you can see the systematic that we have in this bronze, silver, gold. So now after joining the tables, we have to go and pick the information that we need from the second table, which is the birth date. So B date. And as well from this table, there is another nice information. It is the gender information. So that's all what we need from the second table. Let's go and check the third table. So the third table is about the location information, the countries, and as well we connect the tables by the CIID with the key. So let's go and do that. We're gonna say as well left join silver ERP location, and I'm gonna give it the name LA, and then we have to join Y the keys. The same thing, it's gonna be CI customer key equal to LA CIID. Again, we have prepared those IDs and keys in the server layer, so the joins should be working. Now we have to go and pick the data from the second table. So what do we have over here? We have the ID, the country, and the metadata information. So let's go and just get the country. Perfect. So now with that, we have joined all the three tables and we have picked all the columns that we want in this object. So again, by looking over here, we have joined this table with this one and this one. So with that, we have collected all the customer informations that we have from the two source systems. Okay, so now let's go and query in order to make sure that we have everything correct. And in order to understand that your joins are correct, you have to keep your eye in those three columns. So if you are seeing that you are getting data, that means you are doing the joins correctly. But if you are seeing a lot of nulls or no data at all, that means your joins are incorrect. But now it looks for me it is working. And another check that I do is that if your first table has no duplicates, what could happen is that after doing multiple joins, you might now start getting duplicates because the relationship between those tables is not clear one-to-one. You might get like one-to-many relationship or many-to-many relationships. So now the check that I usually do at this stage is that I have to make sure that I don't have duplicates from the results. So we don't have like multiple rows for the same customer. So in order to do that, we go and do a quick group by. So we're going to group by the data by the customer ID, and then we do the counts from this subquery. So this is the whole subquery. And then after that, we're going to go and say group by the customer ID. And then we say having counts higher than 1. So this query actually try to find out whether we have any duplicates in the primary key. So let's go and execute it. We don't have any duplicates, and that means after joining all those tables with the customer info, those tables didn't cause any issues and didn't duplicate my data. So this is very important check to make sure that you are in the right way. Alright, so that means everything is fine about the duplicates, we don't have to worry about it. Now we have here an integration issue, so let's go and execute it again. And now if you look to the data, we have two sources for the gender informations. One comes from the CRM and another one comes from the ERP. So now the question is, what we're gonna do with this? Well, we have to do data integration. So let me show you how I do it. First, I go and have a new query, and then I'm gonna go and remove all other stuff, and I'm gonna leave only those two informations and use it distinct just to focus on the integration. And let's go and execute it, and maybe as well to do an order by. So let's do 1 and 2. Let's go and execute it again. So now here we have all the scenarios, and we can see sometimes there is a matching. So from the first table we have female, and the other table we have as well female, but sometimes we have an issue, like those two tables are giving different informations, and the same thing over here. So this is as well an issue, different informations. Another scenario where we have a data from the first table, like here we have the female, but in the other table we have not available. Well, this is not a problem, so we can get it from the first table. But we have as well the exact opposite scenario, where from the first table the data is not available, but it is available from the second table. And now here you might wonder why I'm getting a null over here. We did handle all the missing data in the silver layer, and we replaced everything with not available. So why we are still getting a null? This null doesn't come directly from the tables, it just comes because of joining tables. So that means there are customers in the CRM table that is not available in the ERP table. And if there is like no match, what's gonna happen? We will get a null from SQL. So this null means there was no match, and that's why we are getting this null. It is not coming from the content of the tables, and this is of course an issue. But now the big issue, what can happen for those two scenarios here? We have the data, but they are different. And here again we have to ask the experts about it. What is the master here? Is it the CRM system or the ERP? And let's say from their answer gonna say the master data for the customer information is the CRM. So that that means the CRM informations are more accurate than the ERP information. And this is only about the customers, of course. So for this scenario where we have female and male, then the correct information is the female from the first source system. The same goes over here. And here we have like male and female, then the correct one is the male, because this source system is the master. Okay, so now let's go and build this business rule. We're gonna start as usual with the case when. So the first very important rule is, if we have data in the gender information from the CRM system from the master, then go and use it. So we're gonna go and check the gender information from the CRM table. So customer gender is not equal to not available. So that means we have a value male or female. Let me just have here a comma like this. Then what's gonna happen? Go and use it. So we're gonna use the value from the master. CRM is the master for gender info. Now, otherwise, that means it is not available from the CRM table. Then go and use and grab the information from the second table. So we're gonna say CA gender, but now we have to be careful with this null over here. We have to convert it to not available as well. So we're gonna use the coalesce. So if this is a null, then go and use the not available like this. So that's it. Let's have an end. And let me just push this over here. So let's go and call it new gen for now. Let's go and execute it. And let's go and check the different scenarios. All those values over here, we have data from the CRM system, and this is as well represented in the new column. But now for the second part, we don't have data from the first system, so we are trying to get it from the second system. So for the first one is not available, and then we try to get it from the second source system. So now we are activating the else. Well, it is null, and with that, the coalesce is activated, and we are replacing the null with not available. For the second scenario as well, the first source system don't have the gender information. That's why we are grabbing it from the second. So with that, we have a female. And then the third one, the same thing. We don't have information, but we get it from the second source system. We have the male. And the last one, it is not available in both source systems. That's why we are getting not available. So with that, as you can see, we have a perfect new column where we are integrating two different source systems in one. And this is exactly what we call data integration. This piece of information, it is way better than the source CRM and as well the source ERP. It is more rich and has more information. And this is exactly why we try to get data from different source systems in order to get rich information in the data warehouse. So with that, we have a nice logic. And as you can see, it's way easier to separate it in separate query in order first to build the logic and then take it to the original query. So what I'm gonna do, I'm just gonna go and copy everything from here and go back to our query. I'm gonna go and delete those informations, the gender, and I will put our new logic over here. So a comma, and let's go and execute. So with that, we have our new nice column. Now with that, we have very nice objects. We don't have duplicates and we have integrated data together. So we took three tables and we put it in one object. Now the next step is that we're gonna go and give nice friendly names. The rule in the code layer that to use friendly names and not to follow the names that we get from the source system. And we have to make sure that we are following the rules by the naming conventions. So we are following the snake case. So let's go and do it step by step. For the first one, let's go and call it the customer ID. And then the next one, I will get rid of using keys and so on. I'm gonna go and call it customer number, because those are customer numbers. Then for the next one, we're gonna call it first name without using any prefixes, and the next one last name, and we have here marital status. So I will be using the exact name but without the prefix, and here we're just gonna call it gender, and this one we're gonna call it create date, and this one birth date, and the last one gonna be the country. So let's go and execute it. Now, as you can see, the names are really friendly. So we have customer ID, customer numbers, first name, last name, material status, gender. So as you can see, the names are really nice and really easy to understand. Now, the next step, I'm gonna think about the order of those columns. So the first two, it makes sense to have it together, the first name, last name. Then I think the country is very important information. So I'm gonna go and get it from here and put it exactly after the last name. It's just nicer. So let's go and execute it again. So So the first name, last name, country. It's always nice to group up relevant columns together, right? So we have here the status of the gender and so on. And then we have the create date and the birth date. I think I'm gonna go and switch the birth date with the create date. It's more important than the create date, like this. And here, not forget a comma, so execute again. So it looks wonderful. Now comes a very important decision about these objects. Is it a fact table or a dimension? Well, as we learned, dimensions hold descriptive informations about an object. And as you can see, we have here a descriptions about the customers. So all those columns are describing the customer information. And we don't have here like transactions and events, and we don't have like measures and so on. So we cannot say this object is a fact. It is clearly a dimension. So that's why we're gonna go and call this object the dimension customer. Now there is one thing that if you are creating a new dimension, you need always a primary key for the dimension. Of course, we can go over here and depend on the primary key that we get from the source system, but sometimes you can have like dimensions where you don't have like a primary key that you can count on. So what we have to do is to go and generate a new primary key in the data warehouse. And those primary keys, we call it surrogate keys. Surrogate keys are system-generated unique identifier that is assigned to each record to make the record unique. It is not a business key, it has no meaning, and no one in the business knows about it. We only use it in order to connect our data model. And in this way, we have more control on how to connect our data model, and we don't have to depend always on the source system. And there are different ways on how to generate surrogate keys, like defining it in the DDL, or maybe using the window function row number. In this data warehouse, I'm gonna go with the simple solution where we're gonna go and use the window function. So now, in order to generate a surrogate key for this dimension, what we're gonna do, it is very simple. So we're gonna say row number over, and here we have to order by something. You can order by the create date or the customer ID or the customer number, whatever you want. But in this example, I'm gonna go and order by the customer ID. So we have to follow the naming convention that's all surrogate keys with the key at the end as a suffix. So now let's go and query those informations. And as you can see at the start, we have a customer key, and this is a sequence. We don't have here, of course, any duplicates. And now this surrogate key is generated in the data warehouse, and we're gonna use this key in order to connect the data model. So now with that, our query is ready, and the last step is that we're gonna go and create the object. And as we decided, all the objects in the gold layer are gonna be a virtual one. So that means we're gonna go and create a view. So we're gonna say create view gold.dim. So follow the naming convention, stand for the dimension, and we're gonna have the customers. And then after that, we have us. So with that, everything is ready. Let's go and execute it. It was successful. Let's go to the views now, and you can see our first object. So we have the dimension customers in the gold layer. Now, as you know me, in the next step of that, we're gonna go and check the quality of this new object. So let's go and have a new query. So select star from our view, then customers. And now we have to make sure that everything in the right position like this. And now we can do different checks like the uniqueness and so on. But I'm worried about the gender information. So let's go and have a distinct of all values. So as you can see, it is working perfectly. We have only female, male, and not available. So that's it. With that, we have our first new dimension. Okay friends, so now let's go and build the second object. We have the products. So as you can see, product information is available in both source systems. As usual, we're gonna start with the CRM informations, and then we're gonna go and join it with the other table in order to get the category informations. So those are the columns that we want from this table. Now we come here to a big decision about this object. This object contains historical informations and as well the current informations. Now of course, depend on the requirement whether you have to do analysis on the historical informations, but if you don't have such a requirement, we can go and stay with only the current informations of the products. So we don't have to include all the history in the object. And it is anyway, as we learned from the model over here, we are not using the primary key, we are using the product key. So now what we have to do is to filter out the historical data and to stay only with the current data. So we're gonna have here a where condition, and now in order to select the current data, what we're gonna do, we're gonna go and target the end date. if the end date is null, that means it is a current data. Let's take this example over here. So you can see here we have 3 records for the same product key, and for the first 2 records we have here an information in the end date because it is historical informations, but the last record over here we have it as a null, and that's because this is the current information. It is open and it's not closed yet. So in order to select only the current informations, it is very simple. We can say brd end date is null. So if you go now and execute it, you will get only the current products. You will not have any history. And of course we can go and add comment to it, filter out all historical data. And this means of course we don't need the end date in our selection, of course, because it is always a null. So with that we have only the current data. Now the next step is that we have to go and join it with the product categories from the ERP, and we're gonna use here the ID. So as usual, the master information is the CRM and everything else gonna be secondary. That's why I use the left join just to make sure I'm not losing, I'm not filtering any data, because if there is no match then we lose data. So left join silver ERP and the category. So let's call it PC, and now what we're gonna do, we're gonna go and join it using the key. So en from the CRM we have the category ID equal to PC ID, and now we have to go and pick columns from the second table. So it's gonna be the PC, we have the category, very important, PC, we have the subcategory, and we can go and get the maintenance. So something like this. Let's go and query, and with that we have all those columns comes from the first table and those 3 comes from the second. So with that we have collected all the product informations from the 2 source systems. Now the next step is we have to go and check the quality of these results, and of course what is very important is to check the uniqueness. So what we're gonna do, we're gonna go and have the following query. I want to make sure that the product key is unique, because we're going to use it later in order to join the table with the sales. So from, and then we have to have group by product key, and we're going to say having counts higher than 1. So let's go and check. Perfect. We don't have any duplicates. The second table didn't cause any duplicates for our join. And as well, this means we don't have historical data and each product is only 1 record and we don't have any duplicates. So I'm really happy about that. So let's go and query again. Now, of course, the next step, do we have anything to integrate together? Do we have the same information twice? Well, we don't have that. The next step is that we're going to go and group up the relevant informations together. So I'm going to say the product ID, then the product key and the product name are together. So all those 3 informations are together. And after that, we can put all the category informations together. So we can have the category ID, the category itself, the subcategory. Let me just query and see the results. So we have the product ID, key, name, and then we have the category ID, name, and the subcategory, and then maybe as well to put the maintenance after the subcategory like this. And I think the product cost and the line can start could stay at the end. So let me just check. So those 4 informations about the category, and then we have the cost, line, and the start date. I'm really happy with that. The next step, we're gonna go and give nice names, friendly names for those columns. So let's start with the first one. This is the product ID. The next one gonna be the product number. We need the key for the surrogate key later. And then we have the product name, and after that we have the category ID and the category, and this is the subcategory. And then the next one gonna stay as it is, I don't have to rename it. The next one gonna be the cost and the product line, and the last one will be the start date. So let's go and execute it. Now we can see very nicely in the output all those friendly names for the columns, and it looks way nicer than before. I don't have even to describe those informations, the name describe it. So perfect. Now the next big decision is, what do we have here? Do we have a fact or dimension? What do you think? Well, as you can see here again, we have a lot of descriptions about the product. So So all those informations are describing the business object products. We don't have like here transactions, events, a lot of different keys and IDs. So we don't have really here a fact, we have a dimension. Each row is exactly describing one object, describing one product. That's why this is a dimension. Okay, so now since this is a dimension, we have to go and create a primary key for it. Well, actually the surrogate key. And as we have done it for the customers, we're gonna go and use the window function row number in order to generate it over, and then we have to store the data. I will go with the start date, so let's go with the start dates, and as well the product key, and we're gonna give it a name, products key, like this. So let's go and execute it. With that, we have now generated a primary key for each product, and we're gonna be using it in order to connect our data model. Alright, now the next step of that, we're gonna go and build the view. So we're gonna say create view, we're gonna say gold and dimension products, and then as. So let's go and create our object. And now if you go and refresh the views, you will see our second object, the second dimension. So we have here in the gold layer the dimension products, and as usual we're gonna go and have a look to this view just to make sure that everything is fine. So them products, so let's execute it, and by looking to the data everything looks nice. So with that, we have now two dimensions. Alright friends, so with that we have covered a lot of stuff. So we have covered the customers and the products, and we are left with only one table where we have the transactions, the sales. And for the sales information, we have only data from the CRM, we don't have anything from the ERP. So let's go and build it. Okay, so now I have all those informations, and now of course we have only one table, we don't have to do any integrations and so on. And now we have to answer the big question, do we have here a dimension or a fact? Well, by looking to those details, we can see transactions, we can see events, we have a lot of dates informations, we have as well a lot of measures and metrics, and as well we have a lot of IDs, so it is connecting multiple dimensions. And this is exactly a perfect setup for a fact. So we're gonna go and use those informations as a fact. And of course, as we learned, a fact is connecting multiple dimensions. We have to present in this fact the surrogate keys that comes from the dimensions. So those two informations, the product key and the customer ID, those informations comes from the source system. And as we learned, we want to connect our data model using the surrogate keys. So what we're gonna do, we're gonna replace those two informations with the surrogate keys that we have generated. And in order to do that, we have to go and join now the two dimensions in order to get the surrogate key. And we call this process, of course, data lookup. So we are joining the tables in order only to get one information. So let's go and do that. We will go with the left join, of course, not to lose any transaction. So first we're going to go and join it with the product key. Now, of course, in the silver layer, we don't have any surrogate keys. We have it in the gold layer. So that means for the fact table, we're going to be joining the silver layer together with the gold layer. So gold dots and then the dimension products, and I'm gonna just call it PR, and we're gonna join the SD using the product key together with the product number from the dimension. And now the only information that we need from the dimension is the key, the surrogate key. So we're gonna go over here and say products key, and what I'm gonna do, I'm gonna go and remove this information from here because we don't need it. We don't need the original product key from the source system, we need the surrogate key that we have generated in our own in this data warehouse. So the same thing gonna happen as well for the customer. So gold, dimension, customer. Again, we are doing here a lookup in order to get the information on SD. So we are joining using this ID over here equal to the customer ID, because this is a customer ID. And what we're gonna do, the same thing, we need the surrogate key, the customer key, and we're gonna delete the ID because we don't need it. Now we have the surrogate key. So now let's go and execute it. And now with that, we have in our fact table the two keys from the dimensions, and now this is gonna help us to connect the data model, to connect the facts with the dimensions. So this is very necessary step, building the fact table. You have to put the surrogate keys from the dimensions in the facts. So that was actually the hardest part, building the facts. Now the next step, all what you have to do is to go and give friendly names. So we're gonna go over here and say order number. Then the surrogate keys are already friendly, so we're gonna go over here and say this is the order date, and the next one gonna be shipping date, and then the next one due date, and the sales gonna be, I'm gonna say sales amount, the quantity, and the final one is the price. So now let's go and execute it and look to the results. So now as you can see, the columns looks very friendly. And now about the order of the columns, we use the following schema. So first in the fact table, we have all the surrogate keys from the dimensions. Then second, we have all the dates. And at the end, you group up all the measures and the metrics at the end of the facts. So that's it for the query for the facts. Now we can go and build it. So we're gonna say create a view gold in the gold layer. And this time we're gonna use the facts underscore, and we're gonna go and call it sales. And then don't forget about the as. So that's it. Let's go and create it. Perfect. Now we can see the facts. So with that, we have 3 objects. In the gold layer, we have 2 dimensions and 1 fact. And now, of course, the next step with that, we're gonna go and check the quality of the view. So let's have a simple select fact sales. So let's execute it. Now by checking the result, you can see it is exactly like the result from the query and everything looks nice. Okay, so now one more check that I usually do after building a fact is try to connect the whole data model in order to find any issues. So let's go and do that. We will do just simple left join with the dimensions. So gold, dimension, customers, C, and we will use the keys. And then we're gonna say where customer key is null, so there is no matching. So let's go and execute it. And with that, as you can see in the results, we are not getting anything. That means everything is matching perfectly. And we can do as well the same thing with the products. So left join gold, then products, P, on product key, and then we connect it with the facts, product key, and then we can go and check the product key from the dimension like this. So we are checking whether we can connect the facts together with the dimension products. Let's go and check. And as you can see as well, we are not getting anything. And this is all right. So with that, we have now SQL codes that is tested and as well creating the gold layer. Now in the next step, as you know, in our requirements, we have to make clear documentations for the end users in order to use our data model. So let's go and draw a data model of the star schema. So let's go and draw our data model. Let's go and search for a table. And now what I'm going to do, I'm going to go and take this one where I can say what is the primary key and what is the foreign key. And I'm going to go and change a little bit the design. So it's going to be rounded. And let's say I'm going to go and change to this color and maybe go to the size, make it 16. And then I'm going to go and select all the columns and make it as well 16, just to increase the size. And then go to our range and we can go and increase it 39. So now let's go and zoom in a little bit for the first table. Let's go and call it gold, dimension, customers, and make it a little bit bigger like this. And now we're going to go and define here the primary key. It is the customer key. And what else we're going to do? We're going to go and list all the columns in the dimension. It is a little bit annoying, but the result's going to be awesome. So what do we have? The customer ID, we have the customer number, and then we have the first name. Now in case you want a new rows, so you can hold Control and Enter, and you can go and add the other columns. So now pause the video and then go and create the 2 dimensions, the customers and the products, and add all the columns that you have built in the view. Welcome back. So now I have those 2 dimensions. The third one gonna be the fact table. Now for the fact table, I'm gonna go with different color, for example, the blue, and I'm gonna go and put it in the middle, something like this. So we're gonna say gold fact sales. And here for that, we don't have primary key. So we're gonna go and delete it. And I have to go and add all the columns of the facts. So order number, products key, customer key. Okay, all right, perfect. Now what we can do, we can go and add the foreign key information. So the product key is a foreign key for the products. So we're gonna say FK1, and the customer key gonna be the foreign key for the customers, so FK2. And of course, we can go and increase the spacing for that. Okay, so now after we have the tables, the next step in data modeling is to go and describe the relationship between these tables. This is of course very important for reporting and analytics in order to understand how I'm gonna go and use the data model. And we have different types of relationships. We have one-to-one, one-to-many, and in star schema data model, the relationship between the dimension and the fact is one-to-many. And that's because in the table customers, we have for a specific customer only one record describing the customer. But in the fact table, the customer might exist in multiple records, and that's because customers can order multiple times. So that's why in facts it is many, and in the dimension side it is one. Now in order to see all those relationships, we're gonna go to the menu to the left side, and as you can see we have here entity relations, and now you have different types of arrows. So here for example we have 0 to many, 1 to many, 1 to 1, and many different types of relations. So now which one we're gonna take? We're gonna go and pick with this one. So it says one mandatory, so that means the customer must exist in the dimension table. Too many, but it is optional. So here we have three scenarios: the customer didn't order anything, or the customer did order only once, or the customer did order many things. So that's why in the fact table it is optional. So we're gonna take this one and place it over here. So we're gonna go and connect this part to the customer dimension and the many parts to the facts. Well, actually, we have to do it on the customers. So with that, we are describing the relationship between the dimensions and fact with one to many. One is mandatory for the customer dimension and many is optional to the facts. So we have the same story as well for the products. So the many part to the facts and the one goes to the products. So it's going to look like this. Each time you are connecting new dimension to the fact table, it is usually one-to-many relationship. So you can go and add anything you want to this model, like for example a text, like explaining something. For example, if you have some complicated calculations and so on, you can go and write this information over here. So for example, we can say over here, sales calculation. We can make it a little bit smaller. So let's go with 18. So we can go and write here the formula for that. So sales equal quantity multiplied with the price, and make this a little bit bigger. So it is really nice info that we can add it to the data model, and even we can go and link it to the column. So we can go and take this arrow, for example, put it like this and link it to the column. And with that you have as well nice explanation about the business rule or the calculation. So you can go and add any descriptions that you want to the data model, just to make it clear for anyone that is using your data model. So with that, you don't have only like 3 tables in the database, you have as well like some kind of documentations and explanation. In one click we can see how the data model is built and how you can connect the tables together. It is amazing really for all users of your data model. Alright, so now with that we have really nice data model, and now in the next step we're gonna go and create quickly a data catalog. Alright, great. So with that we have a data model, and we can say we have something called a data product, and we will be sharing this data product with different types of users. And there is something that every data product absolutely needs, and that is the data catalog. It is a document that can describe everything about your data model, the columns, the tables, maybe the relationship between the tables as well. And with that you make your data product clear for everyone, and it's gonna be for them way easier to derive more insights and reports from your data product. And what is the most important one? It is time saving, because if you don't do that, what can happen, each consumer, each user of your data product will keep asking you the same questions about what do you mean with this column, what is this table, how to connect the table A with the table B, and you will keep repeating yourself and explaining stuff. So instead of that, you prepare a data catalog, a data model, and you deliver everything together to the users. And with that you are saving a lot of time and stress. I know it is annoying to create a data catalog, but it is investment and best practices. So now let's go and create one. Okay, so now in order to do that, I've created a new file called data catalog in the folder documents. And here what we're going to do is very straightforward. We're going to make a section for each table in the code layer. So for example, we have here the table dimension customers. What you have to do first is to describe this table. So we are saying it stores details about the customers with the demographics and geographics data. So you give a short description for the table, and then after that you're going to go and list all your columns in inside this table, and maybe as well the data type, but what is way important is the description for each column. So you give a very short description, like for example here, the gender of the customer. And now one of the best practices of describing a column is to give examples, because you can understand quickly the purpose of the columns by just seeing an example, right? So here we are saying we can find inside it a male, female, and not available. So with that, the consumer of your table can immediately understand, it will not be an M or an F, it's gonna be a full friendly value. Without having them to go and query the content of the table, they can understand quickly the purpose of the column. So with that, we have a full description for all the columns of our dimension. The same thing we're gonna do for the products. So again, a description for the table and as well a description for each column, and the same thing for the facts. So that's it. With that, you have like a data catalog for your data product at the code layer. And with that, the business user or the data analyst have better and clear understanding of the content of your code layer. Alright, my friends, so that's all for the data catalog. In the next step, we're gonna go back to Repo, where we're gonna finalize the data flow diagram. So let's go. Okay, so now we're gonna go and extend our data flow diagram, but this time for the gold layer. So now let's go and copy the whole thing from the silver layer and put it over here side by side. And of course, we're gonna go and change the coloring to the gold. And now we're gonna go and rename stuff. So this is the gold layer. But now, of course, we cannot leave those tables like this. We have completely new data model. So what do we have over here? We have the fact sales, we have dimension customers, and as well we have dimension products. So now what I'm gonna do, I'm gonna go and remove all those stuff. We have only 3 tables, and let's go and put those 3 tables somewhere here in the center. So now what you have to do is to go and start connecting those stuff. I'm gonna go with this arrow over here, direct connection, and start connecting stuff. So the sales details goes to the fact table. Maybe put the fact table over here. And then we have the dimension customer. This comes from the CRM, customer info. And we have 2 tables from the ERP. It comes from this table as well, and the location from the ERP. Now the same thing goes for the products. It comes from the product info and comes from the categories from the ERP. Now, as you can see here, we have cross arrows. So what we're going to do, we can go and select everything, and we can say line jumps with a gap. And this makes it a little bit like better in the visual for the arrows. So now, for example, if someone asks you where the data come from for the dimension products, you can open this diagram and tell them, okay, this comes from the silver layer. We have like 2 tables, the product info from the CRM, and as well the categories from the ERP. And those several tables comes from the bronze layer, and you can see the product info comes from the CRM and the category comes from the ERP. So it is very simple. We have just created a full data lineage for our data warehouse from the sources into the different layers in our data warehouse. And data lineage is really amazing documentation that can help not only your users but as well the developers. Alright, so with that we have very nice data flow diagram and a data lineage. Alright, so we have completed the data flow. It's really feel like progress, like achievement as we are clicking through all those tasks. And now we come to the last task in building the data warehouse, where we're gonna go and commit our work in the Get repo. Okay, so now let's put our scripts in the project. So we're gonna go to the scripts over here. We have here bronze, silver, but we don't have a gold. So let's go and create a new file. We're gonna have gold / and then we're gonna say ddl gold.sql. So now we're gonna go and paste our views. So we have here our 3 views. And as usual, at the start, we're gonna describe the purpose of the views. So we are saying create gold views. This script gonna go and create views for the gold layer, and the gold layer represent the final dimension and fact tables, the star schema. Each view perform transformations and combination data from the silver layer to produce business-ready datasets, and those views can be used for analytics and reporting. So that's it. Let's go and commit it. Okay, so with that, as you can see, we have the bronze, the silver. So we have all our ETLs and scripts in the repository. And now as well for the gold layer, we're gonna go and add all those quality checks that we have used in order to validate the dimensions and facts. So we're gonna go to the taste over here, and we're gonna go and create a new file. It's gonna be quality checks gold, and the file type is SQL. So now let's go and paste our quality checks. So we have the check for the fact, the 2 dimensions, and as well an explanation about the script. So we are validating the integrity and the accuracy of the gold layer, and here we are checking the uniqueness of the surrogate keys and whether we are able to connect the data model. So let's put that as well in our Git and commit the changes, and in case we come up with a new quality checks, we're gonna go and add it to our script here. So those checks are really important if you are modifying the ETLs, or you want to make sure that after each ETL those scripts should run and so on. It is like a quality gate to make sure that everything is fine in the gold layer. Perfect, so now we have our code in our repository. Okay friends, so now what you have to do is to go and finalize the get repo. So for example, all the documentations that we have created during the projects, we can go and upload them in the docs. So for example, you can see here the data architecture, the data flow, data integration, data model, and so on. So with that, each time you edit those pages, you can commit your work and you have like a version of that. And another thing that you can do is that you go to the README. Like for example, over here I have added the project overview, some important links, and as well the data architecture and a little description of the architecture, of course. And of course, don't forget to add few words about yourself and important profiles in the different social medias. Alright my friends, so with that we have completed our work and as well closed the last epic, building the gold layer. And with that we have completed all the phases of building a data warehouse. Everything is 100% and this feels really nice. Alright my friends, so if you're still here and you have built with me the data warehouse, then I can say I'm really proud of you. You have built something really complex and amazing, because building a data warehouse is usually a very complex data project. And with that you have not only learned SQL, but you have learned as well how we do a complex data project in real world. So with that you have a real knowledge and as well amazing portfolio that you can share with the others if you are applying for a job or if you are showcase that you have learned something new. And with that you have experienced different rules in the projects, what the data architects and the data engineers do in complex data projects. So that was really an amazing journey even for me as I'm creating this project. So now in the next, and with that you have done the first type of data analytics projects using SQL, the data warehousing. Now in the next step we're gonna do another type of projects, the exploratory data analysis EDA, where we're gonna understand and explore our data sets. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching and I will see you in the next tutorial. Bye.